निकल गया था क्या तुम्हें? निकल गया था क्या? ठीक है सर, आप तारीख नहीं आ रही क्या? हेलो हेलो धवल सार सुबह जाऊँगी रमेश नहीं हबो
यस सर, यस सर, यस सर।
अच्छा अच्छा और नॉइज किसी आसुची नॉइज
सर सर टिके आସୁଛି ସାର୍, ଟିକେ ଆସୁଛି ସାର୍।
अच्छा अच्छा ଆଉ ଗତ
ଶୁଭା ହଉଛି ସାର୍,
ଗତକାଲିର
ଶୁଭା ହଉଛି।
ଗତକାଲିର ଫିଡବ୍ୟାକ୍ କ'ଣ ଅଛି? କିଛି ଫିଡବ୍ୟାକ୍ ଦେବେ ଗତକାଲି ପାଇଁ?
ସାର୍ ଠିକ୍ ଠାକ୍ ଅଛି, ଭଲ ଅଛି। ମୁଁ ସାର୍ ବିଗିନିଂ ମୁଁ ଭିତରକୁ ଜାଣିନି, ଯାହା ବି ମୋ ପାଇଁ ପ୍ଲସ୍ ପଏଣ୍ଟ ଥିଲା।
ନାଇଁ ନାଇଁ ଆମର ଯୋଉ ଭଲ ତ ଟକ୍ ଗୁଡ଼ା ଭଲ ଅଛି, ବହୁତ ଭଲ ଭଲ ସ୍ପିକର ଆସିଥିଲେ, ଭଲ ଭଲ ଅଛି ଆଉ ବହୁତ ଖୁସି
ଆଜ୍ଞା
ହେଲେ ଲୋକମାନେ ବି। ନା ଆମର ଇଏ ମାନେ ଲଜିଷ୍ଟିକ ମାନେ ଆମର ଯୋଉ
ନା ସାର୍ ଠିକ୍ ଅଛି ସାର୍,
ଲଜିଷ୍ଟିକ
ଭଲ।
ନଏଜ ଫଏଜ ବେଶୀ ନାହିଁ।
ନା ଠିକ୍ ଅଛି ସାର୍, ଠିକ୍ ଅଛି।
अच्छा अच्छा गुड गुड सर नमस्ते सर नमस्कार
नमस्कार नमस्कार गुड मॉर्निंग सो ऑल सेट गुड ଗୋଟେ ସାଉଣ୍ଡ ହଉଛି ମୋ ସଁ 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 ହେଇ ବୁଝିଲ ସେଟା ଏସି ସାଉଣ୍ଡ ନାହିଁ ଏସି ସାଉଣ୍ଡ ନାହିଁ ସେଟା
नहीं सर एसी माने एसी गुट अच्छी और सर्वर गुट अच्छी
ଏବେ କମିଗଲା ତାପରେ ବେଳେ ବେଳେ ବଢି ଯାଉଛି
ଓ ତାହେଲେ सर बोधे
ଠିକ ଅଛି ଚଳିବ ମାନେ ଏତେ ଇଏ ନାହିଁ ସେ ଯୋଉ ପିନ୍ ଫିନ୍ ଟିକେ ଇଏ କରିଛ ଟିକେ ପ୍ରେସ୍ କର ଦେଖିବା ଯୋଉ ପିନ୍ଟା ଯୋଉ ତମର ଇଏ ସ୍ପିକର ପିନ୍ଟା
सर
नहीं से एसी साउंड की सर्वर साउंड लगे
सर्वर साउंड सर एसी साउंड सर बेसी नहीं बेले किंतु सर्वर साउंड मते लागुची माने कंटीन्यूअस साउंड होची पर सर्वर का सर दूर अछि माने 7-8 फुट दूर अछि
ए जो सौ साउंड टा कहीं होची रे एबे टिके बेसी हला एबे बेसी हला
अच्छा
हे देखो मझे कमी जाउ पूरा बंद हो
ताले सर सिस्टम रे देखिया पड़े
तम तमरा येटा बाहर कर दलो स्पीकर टा
सर
नहीं स्पीकर से तळु बाहर करो कंप्यूटर रो बाहर करो बाहर नहीं कंप्यूटर रो स्पीकर टा बाहर करो कंप्यूटर रो स्पीकर पिन टा या ब्लूटूथ एटा
रमेश समझ आया ये रमेश रमेश सुनाई नहीं दे रहा है क्या नहीं मेरे को सुना नहीं दे रहा है रमेश मुझे सुनाई नहीं दे रहा है इस बात से सर बोल रहे हैं लेकिन मैं सुन नहीं पा रहा हूँ नहीं ये तो खुल दिया है इसमें
तुमको सुबह की श्रीनिवास
नहीं ये नहीं इधर आना चाहिए
आप जब उनको बस नहीं जा रहा आप जब उनको बस नहीं जा रहा
उसको बस उस इधर से वॉइस नहीं आ रहा है इसमें सर कुछ बोल रहे हैं ना देखो
इसमें आएगा तो लगा हुआ है ना
नहीं खुल दिया ना
नहीं खोलिले मते से साउंड टा रहउची श्रीनिवास खोलिले मते साउंड टा
तो क्या खोल के नहीं आएगा तब लगा दीजिए
और नहीं सर
अभी देखिए अभी आ जा रहा है
सुना होची
हां
सर ଏବେ ଶୁଣା ଯାଉଛି
अच्छा हो ठीक आउ तक डिस्टर्ब करनी आउ
बोधे सर एटा कन्फ्यूजन सेट ହେଇଛି ବର୍ତ୍ତମାନ ଏବେ
नहीं आउ किसी डिस्टर्ब करिवे नहीं थाओ
ନଅଟା 15 ହେଇଗଲା
रमेश गुड मॉर्निंग नमस्कार तमे अनम्यूट करो टिके
हां प्रणाम सर
प्रणाम प्रणाम तुम्हें अनम्यूट कले गोटे नॉइज कंटिन्यूअस नॉइज से हो रहा है।
वो सर्वर से आ रहा है, सर्वर से सर।
सर्वर से आ रहा है?
हाँ, सर्वर से आ रहा है।
नहीं, बीच बीच में पूरा बंद हो जा रहा है।
अच्छा, अनम्यूट करने से सर अनम्यूट कर
नो
देते
नो,
हैं, एक्सटर्नल साउंड आ रहा है सर, प्रॉब्लम हो रहा है सर।
ठीक है ठीक है ठीक है फिर।
इधर
तो
सर,
व्हेन
सर्वर रूम में बोल के प्रॉब्लम हो रहा है, सर्वर रूम
हाँ,
में
व्हेन
बोल के।
श्रीनिवास सर इज नॉट स्पीकिंग यू कैन मेक इट म्यूट।
जी सर।
So there are only 10 minutes left, so you should get ready. તમે શ્રીનિવાસ, શ્રીનિવાસ, ଶ୍ରୀନିବାସ, हेलो, सुनाओ जी, हेलो, अनम्यूट करो, अनम्यूट करो।
हाँ सर अनम्यूट हाँ सर सुन सर
ଆଉ 10 ମିନିଟ୍ ରହିଲା। ମୁଁ କାଲି ଗୋଟେ ମେସେଜ ପଠେଇଥିଲି ଇଏ ପ୍ରଫେସର ମାଝୀଙ୍କୁ, ବଂଶୀଧର ମାଝୀଙ୍କୁ।
सर
ତ ହି ରିପ୍ଲାଇଡ୍ କି ହଁ ହଁ ଆଇ ୱିଲ୍ ମିଟ୍ ଭର୍ଚୁଆଲି ଟୁମରୋ।
सर सर थैंक यू सर
ଆଉ ଅନ୍ୟମାନଙ୍କୁ ଟିକେ ଟିକେ ସରୋଜ ସାର୍ଙ୍କୁ ସବୁ ମେସେଜ ଗୋଟେ ଗୋଟେ ଦେଇଦିଅ ହ୍ୱାଟ୍ସଆପରେ।
हाँ सर दे सारे सर
ଦେଇ ସାରିଲେଣି।
ये वाला चाहिए? क्या मोबाइल चाहिए? हाँ? मोबाइल चाहिए ना, ये वाला चाहिए? मोबाइल चाहिए। एक वाला चाहिए? हाँ? मोबाइल चाहिए?
मैडम थैंक यू नमस्कार संस्कार मैडम नमस्कार
हेलो। Sir, namaskar, Professor Maji.
Sir, namaskar, sir.
Namaskar. Good
Sir,
to see
namaskar.
you. Namaskar, namaskar.
Namaskar.
Good to see you, sir.
After a long time,
After a
we are
long time.
meeting. Professor
Yeah, yeah.
Udgata.
Yeah, after a long time actually.
Long time, yes.
Sir, good morning. Good morning, sir.
I think we met in TDM, right?
Yes, yes.
After that, no, I had been to your place. After
But that was
or
before.
before that? It was
That
before.
was before that. That was before
Oh,
that.
yes.
You came to our
Srinivas,
place.
how
Good
are you
morning.
doing?
Sir, good morning.
Good
morning, sir.
morning. Good morning, Shashmita.
Good morning, Professor Mishra. Sasmita madam, good morning. Namaskar.
Good morning, sir.
Good morning.
Namaskar.
So, should we start or we'll wait?
We'll wait I mean, all the panel, I mean, all the inaugural members have joined. Professor Satyabrat Mohanto, Professor Patnaik, Srinivas, whether they have joined? Let me check.
Patnaik sir, namaskar.
Patnaik,
Oh,
sir, join, sir. Just
joined.
now join.
Okay.
Sir, namaskar. Patnaik, sir.
Yeah, he'll join. He has joined. He'll unmute it. Yes, sir, namaskar.
Namaskar, namaskar,
Sir, namaskar, sir.
namaskar.
Sir,
Sir,
namaskar,
good
namaskar.
morning.
So, VC sir, how are you enjoying your job?
Sir, bit challenging, sir. Bit challenging.
Challenging.
Bit challenging.
Uh,
As compared to my earlier assignment, this is a little bit more challenging.
Yes, yes, yes.
Actually, Maji sir, he is having another assignment at 10:30.
Oh, okay.
No problem, no problem. I'll be there. Don't worry. But we can start.
We can start here.
How is Sarang? I have not visited Sarang for a long time, quite a long time.
Okay,
I heard that it has grown up much bigger in terms of all spheres.
Okay, we are thinking to call you if it would have been done through the physical mode. Okay, so next year will be
But
trying.
we are almost 2 years stalled now.
Uh-huh.
Look forward to early coming out and do something in person, but
Right.
nature is not permitting.
Mhm.
Yeah, and we are not sure when it will permit us.
Yes.
And it's very unfortunate, uncertain.
Yes.
So that Professor Jiao Gao, he will join?
I pinged him yesterday night. It's a very difficult actually. The time difference and other things are there. But let's see.
Okay. Okay, so we are waiting for Professor Mahanto, right?
Yes.
How many faculty are there in now in Sarang?
Actually, 9 regular faculty then 11 or 12 guest faculty.
12 guest faculty.
So total 21.
You have BTech Computer Science and MCA, right?
BTech Computer Science and MCA. MCA has become 60 seats. Okay, so
66
now,
intake.
at your time, actually, it was 30, I think.
30 only.
30, and now it has become.
We have traveled quite a long.
1990. 90. So I joined this year, 1990. By that time, actually, you were there. I think you were there, and you gone to join in TCS, I hope.
Yes.
And then you came to NIT Raulkela, and
3 decades passed very fast.
right. And we're planning.
I got an opportunity to meet the Barampur people in a PhD Viva. Manas sir and Das sir and all people. I was remembering our old days in Barampur.
They're quite good days actually. They were all good days. With the time, problems became complex. Those were simple problems to solve. And slowly we are into the complex mode. Good. Can we start actually? Getting delayed.
Srinivas sir, can we start? Okay, so he will join later on, I think.
There may be some technical issues. Let us start actually. Yeah.
Okay, so you just make a phone call, last phone call. Then
I think they are calling, but we can start.
So you take the permission, Dr. Sethi. Take the permission.
Sir.
So there may be a technical problem.
There may be some problem.
Sir, start करें sir. Sir, let us.
Please. He must be facing some problem, so let us start.
Could you get a connect with him that what is the difficulty that he's not able to join?
Madam. Mr. Madam.
sir.
मैडम आप कांटेक्ट करथले कोन किछि कहिसथि मेसेज
ना टेलीफोन रिसीव करना कोन असुविधा हेतु बदे
So with the permission of others, let us start actually.
Yes, sir. Yes, sir.
Then we can.
Okay. Sir, due permission from this General Chair, Professor Lalit Mohan Patnaik sir, and Chief guest, Professor Bansar Maji sir, and also Professor Sivakumar Garg sir. I welcome to all of you in the meetings ICMIB 2021. I request Professor Patnaik as a period of the meeting, due to this technical problem, we Professor Mahanta not connected with this one. Okay. So uh, I request for Professor Patnaik to start this event. May I start, sir?
Okay, please start. Thank you.
Okay. Thank you very much. I request Nirupama Lekta and Soru to carry out the process, okay, as per these guidelines. Please.
Beta, you are on the mute mode. Beta, you are mute.
To all the honorable dignitaries, I extend you a very good morning. It gives me immense pleasure to extend a very warm welcome on behalf of the IGIT Saran, who has clubbed all of us on the seminar on Second International Conference on Machine Learning, Internet of Things, and Big Data 2021. I am Nirupa Lenka.
And I am Swarup Prakash Devata, are the anchors to today's occasion. ICMIB 2021 is the go-to conference for researchers, practitioners dealing with machine learning, Internet of Things, and big data. This conference is the second in the series, and the first one was very well received by the research community. This is a place for congregation of experts, researchers, and practitioners.
So as unfortunately, our director, Professor Satyabrata Mahanta sir, is not present, and I'd like to request organizing chair, Professor Sarojananda Mishra, IGIT Sarang, for addressing the occasion.
Thank you very much. Very good morning to all present over here on this online platform. I am Dr. S.N. Mishra, Professor in Computer Science, Engineering and Applications, IGIT Sarang. Welcome you all to this online platform to conduct our second international conference on machine learning, Internet of Things, and big data. That is in short form, that is ICMIB 2021. It is my honor to introduce all the dignitaries of the inaugural function of the esteemed guests present over here to kickstart the conference. At first, I owe my heartfelt welcome the chief patron of the conference, Professor Satyabrata Mahanta, although he is not able to join due to some technical reason maybe. Director, Indira Gandhi Institute of Technology. And about him, actually, he's a constant encourager for this type of conference. And he has completed his BTech in engineering, chemical engineering from NIT Rourkela, and MTech from IIT Delhi and PhD from IIT Kharagpur. He has been selected for fellowship program in Imperial College of London. He has always motivated all of us to participate in various programs. And he has published many papers in national and international journals of repute. And he has taken also and guiding also so many projects. Okay, and we are feeling his absence. Then my revered honorable general chair of the conference, Professor Lalit Mohan Patnaik, and he is popularly known as LM Patnaik. Okay, so National Institute of Advanced Studies and Indian Institute of Science, Bangalore. And his biodata is a vast biodata.
Sir, you are muted. Please unmute yourself. Professor Mishra.
Sorry. So, have you heard the biodata of Professor Mahanta? Okay.
Yes.
So, Professor L.M. Patnaik obtained his PhD degree in 1978 in the area of real-time system, DSc in 1889, in the areas of computer systems and architectures, both from Indian Institute of Science, Bangalore. During March 2008 to August 2011, he was the Vice Chancellor, Defense Institute of Advanced Technology, Deemed University, Pune. Currently, he is an honorary professor with the Department of Electronic Systems Engineering, Indian Institute of Science, Bangalore, and INSA Senior Scientist and Adjunct Professor with National Institute of Advanced Studies, Bangalore. Prior to this, he was a professor with Department of Computer Science and Automation at the Indian Institute of Science, Bangalore. During the last 50 years of his long service, his teaching, research, and development interests have been in the areas of parallel and distributed computing, computer architecture, CAD of VLSS systems, high performance computing, mobile computing, etc. And that is so.
Skip, you go next.
He has
You can Professor Mishra, you can skip.
Okay. I'm
Yes.
skipping it.
Go to the next video.
He has delivered over 300 keynote invited talks at several international conferences, covering a broad range of topics in computer science, engineering, and IT. He has served on several significant committees of leading professional societies, such as IEEE, CSI, IT, and Institute of Engineers Review and Policy Committees of government agencies, such as DST, DBT, MHRD, CSIR, DOS, UGC, AICT, DRDO, DIT, and EPSC, and many more. Okay, so sir, his contribution to Indian higher technical education are outstanding. Sir, we are very much thankful to you.
Thank you. I'm honored. Yeah.
Then it is my honor. It is my honors to introduce. I express my sincere and very cordial respect and welcome to our chief guest of this inaugural function, Professor Banshidhar Majhi, who is now the Honorable Vice Chancellor of VSSUT Bulla. And his biodata is also long biodata, a vast biodata. Still, I will go through some of his achievements. Just a minute, sir. So some problem is there. Okay. Sorry, sir, for delay. So actually he has passed from NIT Rourkela, and he has supervised many PDF theses, and he has successfully produced 21 PhDs and MTech 8 and MTech 60, and from the MCA program 65, and he has published around 103 journals and patented 3 patents, and he has conducted and attended 90 conferences and published 7 book chapters and e-print 7, and his H index is 27 and I-10 index is 94, and he has got the prestigious Global Leap Fellowship by MHRD 2019-20, and he has got Samanta Chandrasekhar Award for outstanding contribution in engineering technology 2016 Government of Odisha. He has got Vidyasagar Award 2019, ICCC SN 2019, and he has got J.C. Bose Gold Medal for Best Engineering Paper, IT 2001. He has received also Gold Medal from Orissa Engineering Congress 2000. He has first class passed in MTech in 1998, and he has got National Merit Scholarship in HSC 1980. And his teaching experience is 30 years, in industry too, more than 2 years. He has reviewed so many books. That's in Software Engineering Practitioner Approach by Roger Pressman, Prentice of India. And he has developed so many courses also, undergraduate 10, postgraduate 8, and FTP workshop conducted, that is conferences 4, FTP is 4, workshop 7, and research interest is image processing and computer vision. data compression, and he is the membership of many professional societies like LMCSI, MIEEE, FIE, then FIET, and LMIUPRAI, and he was the director of IIIT Kanchipuram, and his previous that is your position he held. He was the professor in NIT Raulkela, associate professors, then vice chancellor VSSUT. Now from 6th August 21, he was the director IIIT DM Kanchipuram, Chennai, and he is the mentor director at IIIT DM Kurnool, AP, Dean Academics, Chairman Automation, etc. Sir, we are very much thankful to you, sir, for your presence.
Thank you very much.
Then it is my pleasure to introduce the respected program chairperson of the conference, Professor Shiv Kumar Udgata, University of Hyderabad. And I should introduce him to this conference. So Shiv Kumar Udgata is presently serving as Professor of Computer Science at AI Lab, School of Computer and Information Sciences at University of Hyderabad. He also served as Director of Center of Modeling of Simulation and Design, CMSD, in University of Hyderabad. He was a research fellow at International Institute for Software Technology, United Nations University, ENU-IIST, Macau. His main research interests include wireless communication, IoT, sensor network, intelligent algorithms. He has authored more than 100 research papers published in reputed international journals and conferences. He has worked as principal investigator in many Government of India and other funding agencies, and related applications and application of swarm intelligence techniques in cognitive radio network domain. He has worked as a consultant to Tata Steel Limited, Scientific Analysis Wing, SAG, DRDO, Government of India. He has been awarded with IBM SUR Shared University Research Award for research project, mobile and sensor network based disaster management system with emphasis on rescue management. He has around 8 edited books, volumes published by Springer, and also recently co-authored a book entitled Internet of Things and Sensor Network for COVID-19, published by Springer Nature Publications House. And I am thankful to Shiv Kumar Udgata. Then it is my that is your honors and pleasure to introduce that is your, although he is not present due to some reason, Jiaoji Gao. Jiaoji Gao received his BSc and MSc degrees from Harbin Institute of Technology, China in 1993 and 1996 respectively. He obtained his DSc degree from Helsinki University of Technology, now Aalto University, Finland, in 1999. He has been working as a professor at the University of Eastern Finland, since 2018. Professor Gao has published more than 400 technical papers in referred journals and international conferences. His current Google Scholar Edge Index is 33. His research interests are nature-inspired computing methods with their applications in optimization, data mining, machine learning, control, signal processing, and industrial electronics. Actually, it is a so respected co-program chairs, Professor Srinivas Sethi, IJIT Sarang, and already I introduced Professor Jiaoji Gao, University of Eastern Finland. Professor Srinivas Sethi is a great researcher and skeleton of arranging this seminar. Okay, respected Professor Sasmita Misra, Head Department of Computer Science Engineering and Applications, IIT Sarang. She always encourages these kinds of activities to happen in the department. Respected other honorable dignitaries on this online platform present over here. And last but not the least, all my thanks to all the participants, paper presenters, students, and those who have contributed a lot for the success of the conference by spending their time, brain, and effort. Dear all, this conference will provide many information regarding the current trends and applications in machine learning, IoT, and big data. Many research work would be presented. This is the second annual conference ICMIB 2021 here in IIT Sarang. We are very grateful to all the resource persons, those who have taken pre-tutorial sessions of the conference. I am extremely grateful to our director, Professor Satyabrata Mahanta, for his support for providing all the required infrastructure, particularly intermediate internet supply and power supply. Like many other revolutionary technology of the modern day, machine learning was once a science fiction. However, its application in real-world industries are only limited by our imagination. In 2021, recent innovations in machine learning have made a great deal of tasks more feasible, efficient, and precise than ever before. Powered by data science, machine learning makes our lives easier. When properly trained, they can complete tasks more efficiently than human. Understanding the possibilities and recent innovations of ML technology is important for businesses so that they can plot a course for the most efficient ways for conducting their businesses. It is also important to stay up to date to maintain competitiveness in the industry. By the research paper submitted and to be presented by research scholars, students, and professionals here in this conference would highlight all these result-oriented aspects of these topics during the conference. I hope you all will enjoy the seminar during these days. A panel discussion is also scheduled on 20th second day of the conference before lunch. The topic is AI for societal good in Indian context. Best wishes from my side and enjoy. And one thing, the spirit of continuing research must go on for the development of our nation, research society, and betterment of human race. Thank you all.
Sir, just a minute. Sir, Principal IJT Sarang, Professor Mahanta have been joined, sir, just now.
Okay.
Sir, I welcome to ICMIB Professor Mahanta in this meeting, sir. Thank you, sir, for joining.
Thank you so much, sir. Let's welcome Conference Program Committee Chair, Professor Sivakumar Udkata, University of Hyderabad, to greet on the occasion.
Yeah, thank you. Thank you very much for inviting me. Professor Satyabrata Mahanta, the Director, Indira Gandhi Institute of Technology, Sarang, and the President of this meeting. Respected Professor L.M. Patnaik, General Chair of the Conference. Chief Guest of the function, Professor Vanshidhar Majhi, Honorable Vice Chancellor, V. Surendra Sai, University of Technology, Burla. Professor S.N. Misra, the Organizing Chair. Professor Srinivas Sethi, Convener and the Organizing Chair. Professor Sasmita Misra, Head of the Department Computer Science and Engineering, Applications Department, other chairs and committee members of the conference, participants, authors, delegates, and volunteers. A very good morning to all of you. I, on behalf of the Technical Program Committee chairs, which comprises of myself, Professor Xiao Ji Gao from University of Eastern Finland, and Professor Srinivas Sethi, we extend you a very hearty welcome to this conference. Now, it's really a pleasure to be part of this much awaited inaugural function of the second version of the International Conference on Machine Learning, Internet of Things, and Big Data, that is ICMIB 2021, being organized by this prestigious Indira Gandhi Institute of Technology, Sarang. This pandemic actually threw a lot of challenges at us, and no words of appreciation is enough for the organizing committee who could still pull it off successfully. The conference draws some excellent technical keynote talks and papers, 2 tutorial talks by Professor Vibhudatta Sahu from NIT Rourkela and Professor Nagendra Kumar Suryadevara from University of Hyderabad were held yesterday, that is on 18th December 2021. The overwhelming response for the tutorial talks is really worth mentioning. I think I was told that around 700 participants registered for the tutorials, and the sessions were streamed in YouTube platform also. Close to 400 participants attended through the YouTube streaming, as there was an upper limit on the number of participants that the Google Meet platform can support. So apart from the tutorial sessions, 5 keynote talks led by Professor Lalit Mohan Patnaik from National Institute of Advanced Studies and University of Science, Bangalore, Professor Amit Misra from University of Cape Town, South Africa, Professor Mukti Mahmood from Nottingham State University, United Kingdom, Dr. Tinku Acharya from Videonetics Limited, and Dr. Subramaniam from ICMIB, Germany, are planned in these 2 days. The last 2 speakers, particularly Dr. Tinku Acharya and Dr. Subramaniam, are from the leading industries, and they will be focusing on the industrial view of the development of AI and machine learning in these days. So we are grateful to all the speakers for accepting our invitations and sparing their time to deliver the talks. This time, we started with the advice of Professor L.M. Patnaik, the General Chair of the conference. The technical committee decided to include a panel discussions on the second day of the conference. The panel discussion will be kind of moderated by me, and you have panelists from academia, industry, and even from the student community to present their views. So we are thankful to Professor S.N. Misra. We just had him from IGIT Saran. Dr. Subramaniam, the Chief Technological Officer, ICMIB RF, Germany. Siddharth Venkatramani, the Managing Director, India Operations, EVA Drones Infrastructure. This is also a German company. And Mr. Rohit Bandugala, PhD student at University of Hyderabad, for accepting our request and to be part of this panel discussion. And in fact, we all are looking forward to these talks. Now, for the conference, in spite of the adverse situation and the deadly second wave of COVID-19, we still received around 167 full paper submissions, and we accepted only 59 papers with an acceptance rate of around 35%, which I think that is quite good in any standards. The contributing authors are from different parts of the globe, that includes United States, Iceland, Saudi Arabia, Malaysia, Algeria, Pakistan, and of course India. Now again, within India, the conference received papers from almost all states, ranging from Assam to Gujarat, from Delhi to Tamil Nadu, and from different institutes, including IITs, NITs, central universities, state universities, and many reputed universities and institutes. So all the papers are reviewed by at least 3 independent reviewers, and in some cases by as many as 5 reviewers. So all the papers are also checked for plagiarism and similarity score. I think it was really a tough job for all of us to select the best papers out of so many good papers for a presentation in this conference. We had to do this unpleasant task, though, that keeping the stringent guidelines and strict approval conditions in view. So I will take this opportunity to thank all the authors for their excellent work and contributions. We thank the reviewers from all around the globe who have done an excellent job and of course a tough job. So on behalf of the technical committee, we are indebted to Professor L.M. Patnaik, the General Chair of the conference, for his timely and valuable advice. We cannot imagine the conference without his active support at all the crossroads of decision making, right? We always struggle in the decision making process, and he is always there to guide us. The management of the host institution, particularly the director, Professor Satyabrat Mohanto, the organizing chair, Professor S.N. Misra, Professor Srinivas Sethi, the head of the Department of Computer Science, Engineering and Application, Professor Sasmita Misra, they have extended all possible supports for smooth conduct of the conferences. Our sincere thanks to all of them. Now we'd like to place on record our thanks to all the keynote speakers, tutorial speakers, panelists, reviewers, session chairs, authors, technical program committee members, various chairs to handle the academic aspect, financial aspect, accountancy aspect, publicity aspect, and above all, there are so many student volunteers who have worked for us. Now, we are also thankful to the Springer Nature Publication House for agreeing to publish the accepted and presented papers in their LNRS series, actually. So, I think I also miss it, but although we have missed this opportunity to meet and enjoy the conference physically, but the organizing committee made all arrangements to make the conference enjoyable and a good learning platform for everybody. Hope all the delegates attending the virtual sessions will enjoy the presentations and also use the opportunity to exchange their ideas. Please take care of yourself, your loved ones, and stay safe. Namaskar. Thank you.
Thank you, sir. It would have been a great pleasure to invite conference program co-chair Professor Sao-Zi Gao, University of Eastern Finland, to address the conference. But due to some issues, Sir has not been able to join today. So moving ahead, I would like to invite Head of the Department, CSEA IGIT Sarang, Professor Saspita Mishra Ma'am, to address the conference.
Very good morning and welcome you all present over here on the online platform. I am extremely happy to express that our department is conducting such an international conference, Machine Learning, Internet of Things and Big Data, ICMIB 2021 every year. This year it is the second version. On this occasion, I owe my respect and honor to our esteemed director, compatron, Professor Satyabrata Mahanta, Director IGIT Sarang. I express my sincere thanks and honor to unbeatable guru in this field and genius come General Chair of the conference, Professor L.M. Patnaik, National Institute of Advanced Studies and Indian Institute of Science, Bangalore. I express my special cordial respect and welcome to our chief guest of this conference, Professor Bansidhar Maji, Honorable Vice Chancellor, VSSQT Bulla, respected program chairperson of the conference, Professor Shiv Kumar Udgata, University of Hyderabad. Last but not the least, all respected other honorable dignitaries on the online platform present over here. My dear participants, students and professionals, the theme of the conference is very burning topic. It is the right platform to exchange our ideas among ourselves for the research development for the betterment of human race. We are very grateful to all the resource persons, those who have taken tutorial sessions of the conference. In this conference, we'll discuss the latest innovations in machine learning technology in 2021 from our perspective as a machine learning software development forum. We'll go over 9 trends and explain how the latest innovations in machine learning technology can benefit you and your organizations and professional career in 2022. Last but not the least, my best wishes from my side to all the faculty, students, and staff of our department to make this conference successful. I extend my special thanks to Professor Srinivas Sethi, professor of our department, without whom this type of international conference would not have been successfully arranged. But remember one thing, dear participants, the spirit of research must go on and the development of our nation and betterment for the development of our nation and betterment of our society. Thank you.
Thank you so much, ma'am. Pleasantly, I'd like to invite General Chair Professor Lalit Mohan Patnaik, National Institute of Advanced Studies and Indian Institute of Science, Bangalore, recipient of prestigious awards like Lifetime Achievement Award, Computer Society of India 2017, Mensa Memorial Award for Best Application Oriented Paper, IETA 2016, and etc. It is a matter of immense pleasure for us to have such an honorary legend in between us. I'd like to request Sir to address the occasion. Sir, please.
Chief guest of the function, Honorable VC VSSUT, Professor Bansidhar Maji, Director IGIT, Professor Satyabrat Mahanta, who is the President of the nice morning's wonderful inauguration function, PC Chair, Professor S.K. Udgata, in absentia, PC Co-Chair, Professor J.O.G. Gao, Head of the Department, CSEA, Professor Mrs. Sasmita Mishra, Organizing Chair and Convener, Professor Srinivas Sethi, a key person in the conference, and Organizing Chair, Professor S.N. Mishra, and we have with us all the delegates, faculty members, students, other invitees virtually attending the function, and the comparees for the function, Nirupa and Shwaru. Hope I am audible, right?
Yes, sir.
Yes. Very good morning. I would like to congratulate the organizers for organizing this wonderful function and the conference, giving me this opportunity. This is the second one in the series. We had the first one. The topic is something very relevant, as has been mentioned by the PC co-chair and others. That is machine learning, IoT, and big data. They're all intertwined in a sort of intimate manner. In fact, organizing a conference like this in a place like IGIT Saran is extremely challenging. In a remote place like this in Odisha, organizing the international conference even physically, with physical presence of delegates to take care of all logistics arrangements and all is extremely tough. And virtual organization adds a second round of complexity, like reliability of internet connectivity, bandwidth. There are a lot of technical aspects other than logistics. Okay. There are a number of them whom I owe my gratitude to as General Chair. I would like to profusely place on record my sincere thanks, and I am indebted, grateful to them. The PC Chair, Professor S.K. Udgata, PC Co-Chair, Professor Gao, the Director of the Institute, Professor Satyabrat Mahanta, the Organizing Chair, Professor Srinivas Sethi, who is the fulcrum of this activity. He has been doing everything, okay, keeps pushing people. Then head of the department, the organizing chair, Professor S.N. Mishra, they have all done a wonderful job. And I am grateful, thankful to the keynote speakers. Other than me, I am just for some formality reason shown as the keynote speaker. A general chair, an old bandicoot like me, never gives a keynote speech. We listen to youngsters like our PC chairs who talk, who are active researchers. I am sort of on my professional menopause. I am no more active in writing papers and IEEE transactions, ACM transactions, and all that. So the organizers did ask me, being a general chair, I cannot be adamant. I could not say no. So I had to fill the gap. I said yes. Okay. So I'm thankful to other keynote speakers, the session chairs, reviewers, authors, PC chairs, tutorial speakers, large number of volunteers, that's faculty members, student volunteers, the institution as a whole, the teaching, non-teaching staff who have done really a wonderful job in organizing this conference. From the first, this is the second one. And the very fact that Springer has been interested in printing the proceedings, that itself is commendable. They look at the quality of the papers, quality of the reviews, how good. In fact, Springer sometimes has been very ruthless and harsh to say no and reject accepted papers. Okay. So the PC chairs have tried their maximum, tried their best to maintain this standard and have a good acceptance ratio. So we are trying to go from year to year. Frankly speaking, mine has been only an ornamental job. I have done absolutely nothing. Almost all the work has been done by Professor Udgata and Professor Srinivas Sethi. Between them, they have handled. And this year, I think Professor Gao has provided a helping hand. And local organizational support, certainly Professor Mahanta and Professor Mishra, the institutional support and head of the department, they have provided. But entire technical activity, reviewing, getting papers, all have been streamlined by both of them. Professor Udgata and Professor Sethi, they have been coordinating. And this year, as was mentioned, we are starting with a panel discussion. I thought, let us add something new every year, okay? So that we have some discussion from youngsters, industry participants, like what they feel. And we also had tutorials. Tutorials are good sort of additions in any conference. It is a keynote addresses, invited talks, tutorials. They are good topics. And the participation has been really extremely encouraging. Okay. So the pandemic has some plus points and negative points. So this is a blessing, has been blessing in disguise. I think there are two sectors where we had to face challenge during pandemic. One is the healthcare infrastructure, where all of us had to really face challenges in this country and world over. Second is science, technology, education, conference, research. Okay. Suddenly we were thrown out of gear and said everything has to be done virtual mode, whether classroom teaching, collaboration, conferences, meetings, decisions. But this has had an advantage. Today you can see this morning's wonderful function. We have people say, participating from Hyderabad, Bangalore, Sarang, Burla, and from across the globe, other places, and across the country. This wouldn't have been possible sometimes in a physical meeting. We are not able to attend, we miss. And pandemic, virtual meetings, virtual platform has enabled that. So this has been probably a plus point. Now there is no question of having no show paper presentations. The authors can present their papers. So probably we will have to live with it and manage this one. So this has saved our travel time and other financial components as well, travel expenses, stay, and all that stuff. Of course, we greatly miss the physical interaction. We would have loved to visit IGIT Saran, visit the campus, talk to people, physically network, but then there's nothing one can do. Whatever model we will have to work with, we will have to fit. Okay. Coming back to the topic of the conference, as has been mentioned, this is something topical. The IoT will be, I think, the future technology, whether it is agriculture, healthcare, smart cities, whatever it may be. Whether you talk about our own bodies, our homes, environments, there will be a large number of sensors. They will generate data, but what do you do with the data? Okay. Huge amount of data. As someone said, probably each person on average will generate so much of data. Okay, on an average, you can say if you compute, it will be tremendous. So, like 1.3 billion people of this country, and if you talk about 7 billion people on the globe generating so much of data, what do you do? Obviously, you will have to intelligently process them. That is where all the technologies of machine learning, AI comes into picture with big data. So all of them are linked. IoT on its own has no value. It just generates data. And it gets into, you talk about the big data, all these models, mathematical things, tools, whether Spark, Hadoop, some databases like Hive, and all that stuff, are languages like R, whatever may be there. But with the data, you cannot do anything. You should have visualization tools like Tableau and all that thing. And you should have machine learning algorithms, which essentially learn, update, get some inferences out of that. And there is other component which will generate huge amount of data, our industry 4G, that industrial Internet of Things. Other than telling that Internet of everything, we have IIoT, industrial Internet of Things, or when you talk about cyber physical system, cyber world, physical world. So you have huge amount of data. But then all is not hanky-dory with the AI and ML. There are a lot of challenges, negative problems. It goes through spring and winter. In my talk after the break, I'm going to raise some of them. There are some negative aspects. There are some challenges as well, what we are facing. People talk about data is like oil. So oil and fossil fuel also are in a way linked with what is called environmental pollution, CO2 problems and all. Data also had the same problem. We will talk about that. There are a number of issues related to AI and ML. We should be sort of open to those criticisms and see how to handle that rather than telling that everything is great. So let us hope this serves as a platform to youngsters, particularly faculty members, to interact, come up with new problems, so that their research activities are strengthened. So I would like to thank all of them particularly. I am grateful, extremely thankful to our chief guest, Honorable VC, VSSUT, Professor Banshidhar Maji, because I know particularly how tough it is for a VC of a university to snatch some time to come and attend functions like this. Even in a Sunday morning, normally the schedules are packed. There are some meetings. A VC normally walks from meeting to meeting, looks from file to file, has absolutely no time in his schedule, whether it is Sunday or weekend or night. And that too in a place like Burla, where the pressures of different types during pandemic and missions, he should be extremely busy. So we are extremely grateful to you, sir, Honorable VC, Professor Maji, for taking some time from your busy schedule to be with us. Same is true with our director, IGIT, Professor Mahanta, for being with us this morning. Thank you very much. Stay safe. Take care. Okay. Take care of yourself and your family. Okay. Let's hope we get out of this SMS culture, that is, you have S for social distance, M for mask, S for sanitizer. Okay. Hope we get out of this pretty soon and meet physically. Wish you all the best. Let me wish you all a wonderful Merry Christmas and Happy New Year. And I, as a general chair, want to conclude that if there are any lapses, any problems, I am responsible. You can throw brickbats at me. If there is any credit should go to everybody else, those who have managed this show. Thank you very much. Wish you all the best. Have great fun during these 2 days. Thank you.
Thank you so much, sir. It will be my honor to invite chief guest of the occasion, Professor Banshidhar Maji, Vice Chancellor, VSSUT Burla. We feel blessed to have such a renowned person. Gold medalist for Best Engineering Paper from IET 2001, gold medalist from Odisha Engineering Congress 2000, first class first in MTech CAC among us. Sir, please do greet the occasion with your wiseful words.
Sir, please unmute your mic. Sir, please unmute.
I'm sorry. Yes. It's a common mistake normally we do. Good morning to all of you. Honorable Professor Patnaik, Director Professor Mahanta, IGIT Sarang, Professor Udgata, the Program Chair of the conference, in absentia Professor Gao, Professor Mishra, and Professor Mishra, both Sashmita and Saroj, Professor Sethi, dear students, and also the participants of this particular conference. In fact, it is a privilege on my part to be part of this conference in the inaugural session. My sincere thanks to Professor Sethi, the convener or the organizer of the conference. And in fact, I'm delighted to see Professor Patnaik, Professor Udgata. During the pandemic, we could not meet, and we are meeting at least online. So it is a great delight. So, in fact, as all of you know that already Professor Patnaik has pointed out, this pandemic has never deterred our determination to continue in our endeavors in terms of academics, whether you talk about teaching, learning, whether you talk about conducting a workshop, conference, or whatever it is. This, in fact, through online, we are at least connected, and we are able to take it forward even during this particular bad days or the challenging days. The theme of the conference, as all of you know, that is the call of the day. You know, we are witnessing a lot of technologies, both in terms of hardware technologies as well as the computational technologies. And when we talk about the recent booming technologies, AI, machine learning, deep learning, this IoT, whether cloud computing or big data can never become apart from it. And it is the second conference that is being conducted by IGIT Saran. And this, in fact, as rightly pointed out by Professor Patnaik, that these technologies, whether you talk about AI, machine learning, deep learning, data science, big data, whatever you talk about, they cannot be talked apart, They are all correlated to each other. When we talk about big data, automatically when we want to talk this voluminous variety and veracity of data, mostly unstructured data, because of the several digitizations, we are capturing data in a much larger rate every day, and it is increasing day by day. And as rightly pointed out, when there are more data, in fact, we are very happy that we will process them and we'll get better information. But the challenge is that to process those data, and that too unstructured data. When we talk about your video, audio, text, and images together. But and this has arise because of this advancement in the sensor technology. We are capturing information or capturing data quite faster rate. But if we are blessed with capturing a lot of data, but at the same time we have also challenges to process them. And when we want to process, we now talk about not only processing them and processing them intelligently, so that we get the right information we extract the right information for the right kind of decision. And AI automatically comes into the play. And AI is also playing a big role in our day-to-day life. And just I'm sorry, I'll just take the call for a minute. I'm reaching. I'm reaching. I'm in a meeting. I'll come. I'm coming another 10 minutes. So artificial intelligence is already playing a big role, but in fact, artificial intelligence, this machine learning, deep learning, even if they differ a little bit in their same way, when we talk about
innovativeness. So undoubtedly, this conference will be beneficial for all the participants, no doubt about it. But how you are taking the things, it depends upon the participant. Here, if you are getting any new kind of idea, then it is a great thing for you. So, at last, I am expecting that this international conference on machine learning, IoT, and big data will be definitely useful for all the participants. Further, I am very much thankful to all the guests those who are invited and all the speakers and the participants for sparing their valuable time for this conference. Thank you. Thank you, everyone. Thank you so much. Thank you, sir. Very good. Good morning to all the platform under the director identity and another speaker, Dr. Mohammed Vice Chancellor, another Vice Chancellor, Vice Chancellor. Together, Dr. Lalit Patnaik, Congress Program Committee Chair, Dr. Shilpa Rujata, Geography Dharma, Dr. Finance, who chair this event. Academic Chair, Dr. System, Head of the Department, Safety Identifier, Dr. Punjab of the Academic Committee of ICMIB to this program. I figure to welcome all these delegates of the event and also the event is organized by the Department of Statistics, Academics and Identity Sarah, with the publicity partner of speaker, publisher, platform. The pre-conference speakers are being organized on 8th December to the to covering the topic of public community of cost competence, national data sharing series, and 5 speakers to the having these different topics. The registration code returns numbers, I think it is a good number of visitors number are there. 782 came out to registered and engaged users. And out of this 100 papers, only 59 papers have been accepted for the registered and publication. Out of this, I would like to thank Dr. Lalit Patnaik for sparing his valuable time and guiding us constantly throughout the years, starting from this proposal period. In the year 2020, through guidance, we started the program and successfully completed in the month September 2020. Dr. Shilpa Rujata, Dr. Jyoti Rao have done excellent job to get together on this technical program. Actually, the
what is the advice from this teacher and professor. Now, keynote speaker, there are five keynote speakers, Professor Elizabeth Knight, Professor Alvin Sir, Professor Tito Echero, Professor Muki Ahmed, and Professor Subramani, keynote speakers of Viveka South and Navendra Kumar Sundar. The management of the institute partially, particularly the director of the IJT Saran, Satyavata Mahathur, and organizing chairperson S.M. Mishra, head of department Sasmita Mishra, and all faculty staff have extended all the possible support for this performance of this conference. My sincere appreciation to all of them. I further like to take opportunity to express my gratitude to all these leaders who have not had to finish reviews on time and hence ensure success of this event. I would like to thank all the session chairs, leaders, technical student committee members, and various chairs who handle finance, applications, and publicity, and all overall to several volunteers delegates for this uh, software and contribution from this event. I would like to thank for all the authors for their contribution towards the success of the event to the better spectators. Last but not least, the organizing committee, colleagues, friends, or students who have been working hard to make this conference a grand success without their unfair cooperation, hard work, and dedication. This event would simply not possible. For all the delegates attending on this of session, we enjoy these presentations and are stay safe and healthy. I request all of these delegates to ensure to take care of this pandemic situation. Particularly, I'm very happy that it is busy schedule concern on the giving interest to present the tickets and answers in audience. I also thankful to Professor Rolling on Professor to address to give consent to address the address the consent to the keynote speakers. Thank you all. Thank you. No, sir. Sir, starting of the keynote. Sir, start of this keynote from sir, Professor. I request Professor Sima to chair the sessions and start the proceedings. Please, sir. Because, sir, yes, sir. Yes, sir, come, sir. Yes, sir. Yes, sir. Yes, sir. Full student coming, sir. Yes, yes, sir. I'm not sure. Yes, sir.
बहुत मजा आ रहा है। हमारी बता रहा वो तो वैसे ही आ रहा है। वो कम वैसा स्लो आ रहा है। हाँ बहुत स्लो आ रहा है। तो सर तक वाला ही आ रहा है। हाँ मीटिंग ये कोचिंग दे रहा है। इन्होंने अपना बोलना है वो ठीक जा रहा है देखिए ठीक जा रहा है।
ଆଜିରେ ଭେଲିଡେଟରି କର ନା ବହୁତ ଭଲ ଗୋଟେ ଆଜି କାନା କଣ ଲାଗେ ସେତେବେଳେ ତ ଟେନସନ ହେଇକି କଣ କହୁଛୁ ତ ମୋର ଫିଲ୍ ହେଇଗଲା କାନା କହିଛୁ ମୁଁ ଅଧା ଲେଖାରୁ ମୋର ଅଧା ଲେଖାରୁ ପୁରା ମାନେ ଭୁଲିଗଲି ଅଧା ଲେଖାରୁ ଲେଖା ହିଁ ପଢିପାରିଲି ମୁଁ ଆସିଗଲା ଲେଖାରୁ ଆପଣଙ୍କୁ ଗାଡ଼ି କାମ ଆପଣଙ୍କୁ ଗାଡ଼ି ଯିବାକୁ ଦେଖିବ ଆଉ ସାର୍ ଟିକେ ରହୁଛି ଟିକେ ଜାଣିଯିବେ ତ ଟିକେ ତମେ ଯାଇପାରିବେ ତମେ ଟିକେ ଯାଅ ଗୋଟେ କାମ କର ତମେ ଲେଖନ ବସ ଗୋଟେ କାମ କର এটা ফুটবল খেলার জন্য বাইকটা বাইকটা বলছো সে বাইক কে দেবে ড্রাইভিং লাইসেন্স দুইটা দুটো যদি এটা স্টার্ট দোকান বুঝছো আপনি কি বেশি আর দেখবেন কোটা আপনি বলুন আপনাকে বলুন না আমাকে কালি রাতে যাইতেন আজ সেই হিসেবে আপনি কালি আনি আপনার বর্ষা একটা কথা হলো যে মেঘাই বর্ষা আসছে এই বছরে কিন্তু ভয়টা নয় যে কিছু सेक्टर जल्दी से होगा उसे निकालने का कोशिश कीजिए मोबाइल तो मोबाइल सुनने के नॉइज आती है उधर नॉइज इधर लैपटॉप में आती है लेकिन असली लैपटॉप ठीक है यूट्यूब यूट्यूब यूट्यूबটা यूट्यूबটা চলাও নি यूट्यूबটা চালাই বন্ধ করে यूट्यूबটা এটা কি হয়ে আছে यूट्यूबটা क्लास है हाँ यूट्यूब का যদি ইয়ারফোন দিয়ে শুনো এটা লাগবে তো আছে না ইধর লগে यूट्यूब का কোন আছে যেটা টেস্ট করে পুরো লাগবে ইয়ারফোন দিয়ে শুনলে আমার নয় আছে কিন্তু খোলা তো শুনলে আসছে না কাজ করতে চাপ ভিতরে ইকো আপনার ইয়ারফোন দিয়ে আসছে तो सुबह पक्का लग जाते हैं ग्रुप वर्क कर लो नहीं इसको बंद फटाफट कैमरा कर दो
noisy आ रहा है रमेश noisy आ रहा है
AI development. But luckily, sometime during this period also, we saw some developments in neural networks, perceptron, backpropagation, many of those things. And computing power came with a big bang. Slowly, the interest in this thing came. In between, we had talks of expert systems. They also had their natural death. 1983, we had the cognitive architecture. 86, autonomous car, like the backpropagation. 97, IBM Deep Blue beats Castle over chess. So if you look at this machine, it is not a traditional machine sitting on your desktop. It is the most powerful, one of the very powerful IBM's machine, uses some of the Monte Carlo search algorithms, some of the highly probabilistic methods, optimization techniques, because predicting the game rules, what will happen further down after so many moves, it is a very complex thing. So it needs really sophisticated algorithms and computing machines. Then in 2004, DARPA had the autonomous vehicle challenge. 11, IBM's Watson beats the Jeopardy champion. We had Siri, Cortana, and all that thing we have been enjoying these days, Siri, Cortana, Alex, and all that stuff. 2017, DeepMind's AlphaGo beats the world's Go champion, Lee Chodol. And 2018, first wave of robot taxi started. If you look at some of these games, whether chess, Go, any of these games, There again, narrow intelligence in the specific domain, they can play and do that, play and do that. So, oftentimes what happens, the machine plays against itself, okay, so that it picks up the expertise by having different moves. I'm sorry you may not be able to see this thing. This also talks about what is called your timeline. 1962, if you see milestones in AI, Alan Turing publishes the celebrated paper Computing Machinery and Intelligence in the journal Mind. In the summer 1956, we had the Dartmouth workshop. 57, we have Cornell psychologist Frank Rosenblatt invents the concept of perceptron in neural network, a system that paved the way for modern neural networks. Okay. Then we had the Elijah chatbot, where, as you said, we have the Barovic building in Stanford Cart, one of the first autonomous vehicles. And during 1981 and all, we had the Japanese fifth generation computer system projects, which was essentially to develop high-speed machines, parallel machines for parallelizing AI applications like logic programming, Prolog, Lisp, some of these languages. We had the counterpart of that in India called KBCS, knowledge-based computing system, where many of us have worked. The erstwhile Department of Electronics said, we also will start some projects, how to speed up, parallelize the AI-intensive or knowledge-intensive activities. But then this also didn't see much of the light of the day. It was a failure. Okay. We are 97, IBM's Deep Blue leading the world chess champion. Then we have DARPA Grand Challenge and IBM's Watson beating the Jeopardy, others, number of them. So if we look at AI in general, what does it have? Learn from experience, users learning to reason, recognizing images, solve complex problems, understand language and nuances, creates perspectives, right? What are some of the components like building systems that can do intelligent systems? It is NLP and machine learning, building systems that can learn from experience, and biologically inspired network of artificial neurons, as you can see. We don't use the spiking neuron model, which has probably a complex dynamic equation where you talk about differential equations with dynamics and all that stuff, that is exchange of sodium, potassium ions, chemicals and all that. You use some simple steady state forms where inputs are given, passed through weights, sum of products, exceeds a threshold, it fires, you get an output. Biologically inspired, building systems that use deep neural network. Okay, so it has the components of NLP, knowledge representation, automated reasoning, machine learning. Unfortunately, when you talk about AI, always we seem to concentrate only on machine learning, machine learning. That's not the only thing. It has several things. It has logic, how to reason, whether it is propositional logic, first order logic, what are the things? There is a concept of natural language processing, syntax, semantics, grammar, and what are the ambiguities there? How do you represent knowledge? Is it semantic networks? Is it frames? How do you represent the knowledge? There are a large number of other things. Knowledge storage, knowledge representation, logic, common sense, number of these things. Machine learning is one part of it. Okay, it is not simply when you talk about the AI. So the problem with AI is by far the greatest danger of AI is that people conclude too easily that they understand it, the nuances and issues. So when we talk about AI continuum, it is AI assisted intelligence, augmented intelligence, autonomous intelligence. In autonomous intelligence, adaptive or continuous system that takes over the decision making in some cases, but they will do so only after the human decision maker start trusting this one. Today, to the best of my knowledge, we don't have this type of systems where it is autonomous. Leave it completely to the AI machine or AI system where the machine takes over. It is like assisted, augmented human ability to do the same task force better, Humans still make some of the key decisions, but AI executes the task on behalf of it. Okay, we have both the components, right? Are we able to hear and see? Is it clear?
Yes, sir. Yes, sir. Clear.
No problem.
No problem, sir.
Okay. Why suddenly it is not? Okay, right. So there have been many models. Okay, we starting from traditional perceptron. Perceptron had its limitations. We talked about backprop, that is supervised, unsupervised. You have neocognitron. There are a number of models, bad accent, SUT memory, about a dozen of them. Right? Let us not get into that. So we have, what is the biological inspiration for the so-called deep learning? In 1962, we have two scientists who were conducting an experiment, Hubel and Wiesel, on the cat's visual cortex. When they said, when the light falls on the retina of the cat's eye, how does it see? It passes through the retina, then LGN, V1, V2, V3, LOC, like that. So that is what happens even in human beings. When we see an object, maybe in one level it is pixels, next probably lines or edges, next probably the rectangular formulation, next maybe curves, next probably some colors. At different layers we get our perception. That is why even in a deep convolution networks, you talk about different layers. Each layer is responsible, is having a kernel or a filter. We are not getting into the maths. We go through subsampling and all that things. The filter essentially is responsible for a specific region of the detection. So these models have performed extremely well. The CNN, convolution neural networks, for object recognition, speech recognition, and all that stuff. And when we are looking at a convolution, continuous domain, it is integral. In discrete domain, it is nothing but a summation and product, the expression what you see. Lo and behold, this is very simple to parallelize and do it in a parallel computer because you can perform all the products. Okay, what happens in a CNN, you have a filter, you have the image, you take the dot product of those filter coefficients and the corresponding pixel values of the image, sum of those things, right? So these can be done in parallel. That's why people have been using GPU, CUDA, some of these architectures to get this thing. So deep learning based multi GPUs has been the trend these days. The data processed in deep learning networks can be divided into parameters. These are weight biases in convolution neural network like filter banks, sizes, and all that stuff. So how has parallelism helped? In fact, we have been working on some of these problems during the last 4 to 5 years. The deep learning is a highly compute intensive work. It has the number of vector matrix computations involving linear algebra, matrix multiplications, optimizations, probability calculations, and all that stuff. So you have parallelism in inputs, parallelism in maps, filters, elements within a filter. We talk about data parallelism and model parallelism. What do you mean by data parallelism? You look at an image, it has huge amount of data. So you parallelize that, take different parts of the image, okay, and process them in parallel. This is the philosophy behind data parallelism. Okay, you split it. That each GPU uses the same model to train on different data. The model is same, but the different parts of the image, different data are essentially taken. There is no synchronization between GPUs in forward computing. Okay. So when we talk about in a model parallelism, what happens if you look at any typical learning algorithm? There is number of computations, a mathematical model. There is parallelism in that. So you parallelize that. Different parts of the computation put in different machines, different GPUs, they do in parallel, the entire image is given. So it is splitting the image or data in one case, it is splitting the computation in another case. So you can parallelize in two different ways. In fact, these what we call are embarrassingly parallel system. You can parallelize them, put it on GPUs. Recently, GPU and CUDA architecture has been quite popular. So you can try with that and get them. There is also hybrid of that, what it's called. There is, you can have data model parallelism, that is a combination of both. Essentially, you can have data model parallelism. There is a mix. Model parallelism could get a good performance. Data parallelism, this one, the convolution layer takes almost 90% of computation and 5% for parameters. And you know, in CNN, last part is what you call the fully connected layers, which has 95% parameters and 5 to 10% computation. You can use different tricks. We have been trying to implement some of these parallelism and see what type of performances you get. So this is what happens in a data model parallelism, starting from different convolution layers and going up the fully connected layers. You can parallelize and do that. And they seem to give good performance, right? If you look at the present day, the AI, what happens? We started with machine learning, like it has been implemented. As you can see, you have in Siri, Alexa, Cortana, we have all been enjoying these things. Current technology is the machine learning intelligence here, right? Whether you talk about feed forward, CNN, LSTM, the recurrent neural networks with feedback, physical feedback from the output to the input, which are good for speech processing, NLP, language translation, online real-time language translation, some of these things. So in these applications, it has performed extremely well. But then, when you talk about NLP, language processing, traditional RNNs have some problems. So we go in for what is called LSTM, long short-term memory, using what are called that IFOG gates, okay, where you give sort of permit something, stop something from progressing, and how far it can remember the past, for how long, you can control these things. They have done wonderfully well when compared to human beings when it comes to the translation. But then there is one thing which is lacking in present day machines. Machines are not conscious. We human beings are conscious. Okay, we have wakefulness. Okay, again, consciousness is different type. For example, when you are performing yoga, it is one type of consciousness. When you are in anesthesia, it is one type of consciousness. When you are dreaming, it is one type of consciousness. And when I'm giving a talk, you are listening hopefully to my talk, it is another type of consciousness. And if you ask me who am I can tell. Can the machine tell who is that machine, or can the robot tell? So these are some of the interesting issues of feeling, sentience, sapience, knowledge, wakefulness. Can a machine have that? Now, the people are working. The AI community was not interested in consciousness in these things. So this is a new area now coming up called artificial consciousness or machine consciousness. In fact, at NIAS, I'm spending a little bit of time interacting with philosophers, psychologists, physicists, mathematicians to understand some of these issues. Can a machine be conscious? There are two divergent opinions. There is one group which says no, God has made the human beings, only human beings can be conscious, and intangible, these other objects can by no means be conscious. It is just not possible. There are different theories like panpsychism and all. They say that everything can be conscious. Let me not get into that psychology, philosophy, and all that. So this is an interesting topic. There are simulators available and how you can test, implement. In Nokia, there is the well-known engineer who is doing some work in this thing. He is building hardware, software. He's building hardware using chemical, biological sensors, how to have touch, sense, feeling, everything, right? So that you can have consciousness in these machines. His name is Pentti Haikonen. He is doing wonderful work. So there are a lot of interesting issues. So now the challenge is people are looking at, can they be conscious or can they be partially conscious, semi-conscious? Because if the future machines like robots, if they should have empathy, love, affection, consciousness is very important. When they want to attend to an elderly person, a patient, when you pat on their back, they should feel happy and sometimes they should feel angry. This consciousness is something very important. Robust self-modification. How can AI systems modify themselves while retaining the safety property? Okay. This is again something of interest to computer scientists. People recently have been using the concepts of the theorem proving verification techniques of machine learning methods. Okay. Like one of the important questions, is the machine learning algorithm correct? Does it behave correctly? Does it give me the correct result? Like a program is correct. So how do you do that? When you talk about correctness of programs, you use some formal mathematical tools. Now, verifiability has been of interest to computer scientists, theoretical computer scientists, to see whether machine learning algorithms can be verifiable, whether you can be verifying for their correctness. There have been many applications of AI systems, let me not get into that, which have been positive, good things like breast cancer. Most commonly diagnosed cancer in women, 2.1 million cases was in 2018. Mammography is the gold standard. Image processing techniques, machine learning algorithms, as you know, have been used. Diabetic retinopathy is another deadly disease. 400 plus million diabetes patients at risk. So you take the fundus image, analyze using image processing, and use machine learning technique for that, classify damages caused to the retina. It has come very handy during pandemic. Where should PPEs and ventilators be sent? Which population need most help? Professor Sethi, Professor Sethi,
Yes, sir.
is
Yes,
it
sir.
possible to
Sir.
ask others to mute their this one? I think there is a lot of background noise, vehicles and all that. Okay. How can
Okay,
strain
sir.
be
Thank you. Sir,
eased
I will
on,
inform to.
yeah, how can strain be eased on doctors? Okay. And physicians can keep off from danger, can do more therapeutic work and less paperwork. AI helps in early diagnosis, providing treatment at an early stage, providing best training to doctors and students. Okay, this can act as an assistant and a teaching assistant, can provide more predictive and preventive health care, help in vaccine development. As you know, using the concepts of molecular biology, okay, protein structure analysis, and the culture of previous viruses and the vaccine development in the past for different types of viruses, you can do analysis using computational techniques, machine learning techniques, develop new types of vaccines. And this has been used. It is not a sort of science fiction or prediction. People have been using it during the pandemic time. AI can help in early morning of alerts like tracking and prediction, data dashboards. As you know, Russia, even in India, have been trying using a combination of an app and QR system to track infected people. Vision and robots will be used for social control. And a cheap thing is to use X-ray control. X-ray is much cheaper than PET, CT, SPECT. Some of these the images available in most hospitals, health centers have been used to detect COVID-19 cases, and model with 19 convolution layers in CNN have used with 5 pooling layers, given almost like 98.08% accuracy. AI systems at present are constrained by lack of data. We have huge amount of data, but the question is, do we have for the right type of demography, like our own type of application and things like that? That is what it is. One. After the infections are gone, the surveillance and other data may be misused. That is a risk because a lot of data is being collected that should not be misused. We should keep track of that issue, right? So why I was mentioning this, it has the number of application in the present scenario in the sense of sometimes you have this problem. Okay, right. Applications of AI system, for example, internal labs. This has been used for something for getting to look at like the quality of food. This one, food quality assessment by image processing, grading techniques using image processing and ML techniques. Okay, you can take the images, tell a simple thing which are good the tomatoes and rotten ones, cheaper than hiring a separate resource, removes human intervention in these things. Even in Indian context, like government of Karnataka has used it for price forecast for essential commodities 3 months in advance to plan minimum support prices, and Apollo hospitals for predicting cardiac diseases, government of Andhra Pradesh for predicting the probability of student dropouts across more than 10,000 schools. World's first AI news anchor came up in China, okay, just imitating, explaining the thinking behind this new technology and looking like the real news anchor. AI for Earth, like climate change, sustainable land use, clean air, clean water, pollution control problems, okay, water security, drought prediction, okay, filtering, any of these things, handling energy issues, number of these things, governance and policy. How can we help policymakers manage and societal impacts of AI? It's useful. Anomaly detection. This is something very important, which AI sometimes finds it very difficult. How can AI systems recognize when they're in an unfamiliar setting and generalize from their past experiences? It is not an easy problem. There are known knowns. There are things we know, we know. We also know there are known unknowns. That is to say, we know there are some things we don't know. But there are also unknown unknowns, the ones we don't know, we don't know. It's an interesting sentence. Okay. So we human beings have that ability. Can the machine do that? It is something challenging. There are many other applications in molecular design. You want to design a new material for solar energy, drug fighting cancers, or to make enterprises faster. Okay, drug discovery. And in 2018, IBM demonstrated a chatbot that won a debate competition against an expert and proved superior in one of the two rounds. So when you talk about responsible AI to augment human ingenuity, what are some of the issues? It should comply with societal government norms and regulations.
Hello? It's black, is it? I'm just checking what happened. Srinivas? Hello?
Points and all.
Yeah.
If you look at the technology today, yes,
No, in between I was not able to listen, so I thought it is stuck or something. Now it's okay. Thank you, sir.
is it okay?
Yeah, now it's okay. Yeah.
Oh, is there any problem from my end, Professor Udgata? No.
I don't think so, sir. I don't
Yeah,
think so.
okay. Yeah. So if you look at the technology today, lack of explainability, let us take in the x-axis explainability, y-axis the predicted accuracy. Okay. If you take a simple thing like deep learning, which we talk about, the prediction accuracy is fairly good. You may boast about 97%, 98%, 99%. There are many, as you know, imaging concepts every year, competitions, awards, and all that thing, right? ImageNet and all contests we find. But the explainability is very poor. Okay. If you ask why deep learning works, why it has worked like that, why this is, unless you simply say that there are different kernels, filters, it does that, then you have at the output layer, they're fully connected, there is soft match and all that thing. You talk about that with these probabilities, everything coming. But then why it works, how it works. In fact, there has been a recent paper also, people have used principles of quantum computing to explain why deep learning, deep networks work. So if you look at different methods, but whereas if you take a simple thing like decision trees, the accuracy may not be good, but the explainability is very high. We can very easily know why a decision tree has taken some decision by tracking that. So there is a sort of balance between explainability and prediction accuracy, what you get. So the AI, what we have to do that. What are some of the risks? Okay. That is performance risk, risks of errors, risks of bias. Bias is something important. We will talk in little bit of detail if you have time toward the end. We don't have much time. Okay. It can be biased, gender bias. Okay. Some jobs it may go for men, not women. Some titles it can give for men, not women, like scientist, professor, okay, engineer. And if you look at, there is a tool like Compass, which has been used in US for the granting bail, parole, and all that thing. It went against blacks because the tool essentially finds out what is the probability that the person will commit the same mistake once again. Based on that, you decide whether to grant bail or not. The judge uses that. But they have done extensive amount of study, found that this is no good. It was biased against black. Similarly, sometimes you are biased even in a city based on a zip code, okay, pin code. In some areas, there are highly affluent, rich people live, and if the bank manager sees that the application comes from that area, sanction loan. If it comes from a poor slum area, something, don't give loan to that person. There are different types of bias we human beings have. This is data bias, algorithm bias, and we human beings have created that. The AI also is with that thing. Now we have problems. It has to be fair. That is what is called fairness in machine learning algorithm. Okay, that is it is an important component. Risk of opaqueness and black box risk. It is a black box. Okay, risk of explainability. That's why we said XAI. Risk of the stability of performance. It should be stable. Security. There should not be any cyber intrusion. There should not be privacy risk. Control risk. Risks of AI going rogue. Like robots should not go against us. They should listen to us. They should not go and strike. The inability to control malevolent AI. We cannot do anything. Ethical risk. Lack of values. They don't have any value system. It is very difficult to teach that. Value alignment risk, goal alignment risk in life. Okay. Economic risk. We talk about job replacement risk. Okay. And liability risk. But then this is not correct. When automation came toward the end, if you have time, I will comment. When automation came, people say from industries, from banks, everybody will be thrown out of jobs. Computers have come, they will take our jobs. People are not on the street. In fact, there are more number of jobs, but different types of jobs. Who imagined that the type of jobs today we have, okay, nobody could tell 20 years back that this type of jobs will be there. What will come after 10 years? We don't know when the robots come. You may have to have engineers to train them, to maintain them, okay. You have different types of background, type of people. You may have different types of jobs. It is not jobs going, okay. One has to reorient. Risk of autonomous weapons proliferation. Should you make autonomous weapons? Leave it to them. So it may be mass destruction. Okay. Risk of intelligence divide, like poor, rich, have nots, and all that thing. This is something interesting. Recently, people are talking about colors in artificial intelligence. What do you mean? The title looks very interesting. What do you mean by color? Recently, people have been talking about green and red color in machine learning algorithms. Red machine learning algorithms are those which consume huge amount of energy. Okay, they have problems. Green is one who consume least amount of energy. So, like everything you are talking about, green, 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 you should have green machine learning algorithms, energy efficient machine learning algorithms. There was a time researchers were working on energy efficient routing algorithms in wireless sensing network. Now we will talk about energy efficient ML algorithms. Okay, it should consume least amount of energy because some of them are horrendously bad as far as energy consumption is concerned. If you look at this simple PPT, how much of carbon dioxide emission is there in pounds based on the data? The Strubel and his group from University of Massachusetts have done some studies. Some of these reports have come hardly a month or two ago in some of the IEEE transactions and magazines, only during October, November. Okay. If you look, there are different tools for NLP they have used. Okay. The one is called Transformer, which has 13 million parameters. Okay, NLP, which can do translation, answer your questions in different languages, different types of powers they have developed. With what is called the neural architecture search, it generates 626,155 carbon tons of carbon dioxide. Well, sorry, so many pounds of carbon dioxide. Okay, if you compare with that, what is a typical US car, including fuel, in the lifetime? How much? How many pounds of CO2 it generate? 126,000. American life average per year 36,156. Human life for 1 year 11,023. One passenger round trip flight New York to San Francisco 1,984 pounds of carbon dioxide. So if you can see how some of the sophisticated ML algorithms, what they contribute to pollution, environment, CO2. That is why they're now attributing it to what are called red ML algorithm. Okay, CO2 is a problem. You look at this figure from 2012 to 2018. We have the year. The y-axis says computation demand is measured in the number of addition multiplication operations. This is called petaflop seconds per day. What is it? Number of computing days. That is, you based on 10 power 15 operations per second. You calculate based on that, do that. For some of the deep Q network, visual geometry group, ResNet, some of these networks, if you do this analysis, computing in AI projects has doubled every 3 months since 2012. Tremendous. And there has been 300,000 times the rise since 2012, the computing need. Okay. If you calculate this, you can do very simply, find out the kilowatt hours required. And the US Department of Energy has come out, work that is available, a simple equation for how much of carbon dioxide emission and production. It is equal to CO2 is equal to 0.954 pt, where CO2 is in pounds per kilowatt hour it is given, and the energy you can give it in kilowatt hours, compute and find out how much of CO2 you get from these things. This is another PPT. It shows equivalent carbon dioxide emissions. Okay, you see the year and you see the percentage error. Okay, like if you want to bring it to something like 5% error in some of these algorithms by 2025, equivalent carbon dioxide emissions in pounds, that is computations billions. If you see that, and percentage error to how much you get per year, that it shows CO2 generated by average US resident in 1 year, CO2 generated by average US resident. So extrapolating the gains of recent years might suggest that by 2025, the error level in the best deep learning systems designed for recognizing objects in the ImageNet data set should be reduced to just 5%, as you can see. But the computing resources and energy required to train such a future system would be enormous, leading to the emission as much carbon dioxide as New York City generates in 1 month. Okay, so you can see the problems involved in these things. They have tried the different models, Elmo, BERT, GPT, GPT-3, GPT-3, some of the very recent ones used by the AI projects. Okay, and if you look at the model size, how many parameters, training data size, and year, from these are the ones which consume huge amount of energy. Okay, so that is where now people are concerned about to talk about green ML algorithm, energy efficient algorithms, where you address the issues of model size, training data size, model hyperparameters, algorithmic hyperparameters, and all that thing. And there are some quantitative techniques as to how to control the energy, how to measure the energy, and do that, what tricks you develop to do this. So what are some of the revealing ways where AIs fail? Okay, neural networks can be disastrously brittle, forgetful, surprisingly bad at math. Okay, all of us, we have known, take a typical backprop algorithm, you have trained it to recognize number 1 and 2, it has stored the coefficients, but the moment you train it to maybe recognize 3 and 4, it forgets the previous one. We have these problems of stability, plasticity dilemma, as you know. Okay, it is a very big problem. An AI system can only recognize a pattern it has seen before. If you show a new pattern, it is fooled. Okay, so when you, as you can see, even if a single pixel, few pixels change, it finds it very difficult. It is brittle, it has embedded bias, catastrophic forgetting, okay, forgets things, explainability. What you see in the robo left side trying to explain things there, quantifying uncertainty, okay, common sense, which is pretty tough, and maths, doing math. For example, when you see common sense, a robo is sitting on the right side, cutting the branch of a tree on which the robo is sitting. So there are issues of this one. And in one of the previous things, I think I talked to you about fake, differentiating between the real and fake content. These are also challenging thing. We don't have time to get into GANs. Now GANs are being used extensively for the generating fake images. All of us know fake news, fake images. And the interesting thing about AI, machine learning algorithms, they're used to generate that and they're used to detect that. Okay. And I'm sure most of you have visited this site, www.thispersondoesn'texist.com. If you see, the celebrity pictures, images are generated by taking the nose from one image, hair from another image, ear from another image, lips from another image. You get wonderful images you can't find out. Okay, how is this one? So these are some of the weaknesses where you find. So that is why people are raising some concern. Not ordinary people, celebrities. Okay, like Steve Wozniak, Apple co-founder, said the future is scary and very bad for people. Okay, then Elon Musk, one of our greatest engineers of our times. Okay, Tesla chief executive. AI is a demon that is potentially more dangerous than nuclear weapons. Of course, if you don't use carefully. Okay, Bill Gates says, I don't understand why some people are not concerned about these issues. I'm not making you scary, telling it the negative, but one has to be very careful. Like every technology, whether it is nuclear, internet, digital, or for that matter, simple thing like fire, one has to be very careful about its usage. Then Stephen Hawking was extreme probably. He said full artificial intelligence could spell the end of the human race. Okay. So what is the bias has many facets, like training data bias, the most common, okay, algorithmic focus bias, then emergent bias, context bias, number of these types. The other issue which comes in AI is message trustworthiness. Should we trust this message? Can we trust a robot? That is, robots must be designed to be trustworthy. Okay, there are issues of ethics. Okay, so when you go to philosophy, okay, psychology, some of these streams, you find different theories, what is called deontology, utilitarianism, and virtual ethics. Okay, computer scientists, those who develop algorithms, have borrowed some of these features into AI, into machine learning particularly in recent times. I've been seeing developing algorithms and studying that thing. What does deontology says? Express the morality and ethics in terms of obligations. Like we have the 10 commandments. Okay, thou shalt not do this, thou shalt not do that. Similarly, Asimov's 3 laws of robotics. Okay, it should not do this, it should behave like this, it should behave like this. Utilitarianism maximizes the quantitative measure of utility. This is a little bit of mathematical. You come up with what is called a utility function and try to maximize that so that it performs ethically. Virtual ethics. It is like individual learning through experience and practice. A computational model, it is like a case-based reasoning, rules. If this happens, do like this. This doesn't happen, do like this. Okay? These are some if-then-else type of reasoning type of thing. An ethical agent must be able to explain and justify the actions and decisions. That's what I said explainability. Social norms vary from society, so robots must, the behavior will also vary. Self-driving cars may well be the first widespread examples of trustworthy robots. Okay, this is an interesting thing. We have heard about a case where a pedestrian was killed by a self-driving car. We may have autonomous, semi-autonomous vehicles. So if there are some people sitting inside, if there is a if the driving car, if it sees a cat in front, a pedestrian in front, a dog in front, what should it do? Should it kill the dog or should it hurt the passenger sitting inside? It is an ethics issue, a dilemma. How does it solve? So what people have done is studied from the simple things like prisoner's dilemma. Again, we don't have time to get into that. Two prisoners are put in two prisoner cell. How do they testify? So that if they testify one way, it is advantageous. Okay, they will get free. The other person have problem, but testify the other way, it is something else. It has been found that it is something like a game theory problem leading to mass equilibrium. The optimal solution, what it comes, is an interesting solution. It comes where both of them go to some amount of sentencing without either one getting free. Is like an optimal solution. Zero-sum game theory concept, zero-one game theory concepts have been used. And people are trying to use these things and extending it to what is called from prisoner's dilemma to deadly dilemma, a number of these things. Okay. And there are a number of interesting studies, papers have appeared in journals like AI and Society, where there are talks about how our verification, programming language, correctness, formal techniques can be used to do this thing, to check this thing, starting from very simple problems you find to very complex problems. So moral and decisions must be made very quickly. We don't have much time. When the autonomous vehicle going on the road, it cannot use a sophisticated algorithm, right? Complex decisions for moral and ethical actions involve learning and accumulated knowledge. Physical and social environment is very complex and real-time decisions have to be taken. We could have an AI which understands the world around us but doesn't have significant influence on it. We should have what are called active AIs, need for AIs which also incorporate, possibly learn human values. This is what is called inverse reinforcement learning. Like how do you come up with what should be the best type of decisions or the payoff function you decide. Since humans themselves do not agree on ethics and values, some form of learning will be a necessary ingredient. How will we train wise AI? If you look at the AI perspectives beyond 2020, it can be technology-centric perspective, which claims AI will outperform the human beings. Human-centric perspective, humans will always remain superior. Collective intelligence, both humans and artificial intelligence lies in collective intelligent agents. Okay. There have been many troubling trends with AI tools. Yeah. Let me at this stage pause and ask how much time do I have more? Because
sir, the other speaker is also ready, and
okay.
He has already joined from.
Okay.
So, I mean, actually, the talk is his talk is scheduled at 11:45, but you can continue for some more time.
No, some more time means what? Shall I?
Another 5 minutes, sir. Another 5 to 7.
Okay, fine. Yeah, I had much more material. I'll cut short. Okay.
Yes, please, sir.
There have been many troubling trends with AI tools. Microsoft chatbot Tay was taken down less than 24 hours post its launch for making sexist and racist statements. Amazon's AI-powered recruitment tool was withdrawn for not being gender neutral. Facial recognition tool in China wrongly shames a billionaire businesswoman as a jaywalker. There have been several of these problems where AI decisions have been goofed up. As I said, there have been problems. Okay, due to lack of time, I am not going through that. Like in 2015, programmer Jackie Alcin and his friends, both blacks, were labeled as gorillas by Google's photo app that uses machine learning. As I showed, Compass was deployed in criminal justice system to decide about arrestees' eligibility for bail. The tool was found to erroneously predict based on racially biased patterns. Okay, and even in China also, many of the face recognition algorithms have got into some problems. There are many issues of these AI tools trying to take some wrong decisions. That is what I mentioned. There are problems of bias is considered to be a disproportionate inclination or prejudice. Okay, and this is critical to develop and train systems which mitigate this thing by using some bias mitigation algorithm. So AI expert calls for end to UK use of racially biased algorithms, and the AI problem is recognized but still unresolved. There are many of them who have voiced concern. There are different types. You can have historical bias, you have representation bias, you have measurement bias, different types, learning bias, aggregation bias, number of them, the statistical bias. The Georgia Institute of Technology indicated that autonomous vehicles might have a more difficult time detecting pedestrians with a darker skin. Those cars were programmed mostly by young white male engineers, so the systems were 5% less accurate when recognizing people who have a darker skin. Okay. The professional networking site LinkedIn was discovered to recommend male variations of women's names in response to search queries. There have been many of these things which have been reported in terms of bias. Amazon tried to use AI to build a resume screening tool to make process of sorting through job applications. Okay. A recent research article in Sciences showed an algorithm widely used for population health management to predict which patients will benefit from extra medical care has a significant racial bias. Okay, several of them. In fact, you get number of this data to perform this analysis when it comes to arrests and all that thing. I'm not getting into what are the different types of like biases you talk about, fairness, their metrics, bias types, okay, how do you get, where you get it, and there are a number of data sets available on the web to conduct these studies like Compass, UCI, then German credit databases, like you said, recidivism, like if someone is given a bail, what is the probability that the person will recommit that offense? There have been studies. And many studies, for example, assessing gender bias in machine translation. It has been found with the Google Translate. Translating sentences from a gender-neutral language, such as Hungarian to English, provides a glimpse into phenomenon of gender bias. Okay, that is, the screenshot from Google Translate shows how occupations from traditionally male-dominated fields like scholar, engineer, and CEO are interpreted as male, while nurse, baker, and wedding organizer is interpreted as female. Okay, so there have been many of these things. One can see that adjectives such as shy and desirable, sad and dumb, are female side of the spectrum, contrasting with proud, guilty, cruel, and brave were exclusively male pronouns. So Google Translate included a new feature presenting the user with feminine as well as masculine official translations. One is to define these things, what are called group fairness, individual fairness, number of these types. And we get into what we call the studies based on confusion matrix. We have true positives, false negatives, false positives, true negatives, and all that. Calculate based on that, get some metrics, and perform some studies on this. Okay. The issue primarily I'm trying to say is one has to handle this problem of bias and fairness. Interestingly, there are some tools available in open source bias audit toolkit for machine learning developers called Aquitas, that is developed by Center for Data Science and Public Policy in Chicago. You have some of the database. In fact, we ourselves have used some of them, find it extremely interesting and useful. Okay, we have AI Fairness 360 by IBM. Again, it is a public domain tool one can use, get number of these parameters, do study, and develop your own algorithms to sort of mitigate bias, make them fair, okay, and see how it improves by looking at the performance parameters. You have fair test is another tool, number of these available, and how you manipulate in the machine learning algorithm by dropping certain things. A multitask network is learned for gender and ethnicity prediction, and the algorithm, which is called filter drop, removes the convolution filters responsible for encoding a given sensitive attribute. You can see at certain level, if it is responsible for encoding certain feature, you can drop that in the filter. These types of tricks have been used. Of course, we don't have time to get into that. This is only the part of the thing to conclude what is called the research and practitioners, different disciplines, progress and identifying this. I did mention about the eras of automation starting from 19th, 20th, 21st century. There have been concerns about job replacements when we have automation coming. As you know, there is few occupations are fully automatable. 60% of all occupations have at least 30% technically automatable. So if you look at the impact of AI employment in India, there have been some studies. What will happen in different areas like agriculture, manufacturing, retail, communication, transportation, it has been found that it is not all that bad or all that negative. There will be improvement or additions. So the issues are unemployment, distribution of wealth, impact to human interaction, machine mistakes, bias, singularity, competition for AI supremacy, population control. Will we run out of jobs because of AI? If you look at the Tim O'Reilly's statement, no. Technology is there to solve. We will have new types of problems. And when you have issues like this, the fatality and all, who to blame? These are like the deadly crashes. As I said, there are many issues. You say the problems come with most of the driver-driven vehicles because they text messages, use mobiles while driving. Hope the driverless cars also don't get into that pattern. Okay. So if you look at the surveys of will AI take over human beings, will they be super intelligent, what Nick Bostrom predicts, there have been many studies conducted. Okay, AI systems probably with greater than 50% probability reach overall human ability by 2040, 2050. Very likely 90% probability by 2075 will move to super intelligence in 2 years. That is only 10% probability to 30 years, greater than 75% probability. So there has been mixed response. People say that it may take a lot of time. 76% of CEOs are most concerned with the potential of bias and lack of transparency when it comes to AI adoption. We have issues of ethics like good, evil, right, wrong, virtue, vice, trust, and claim. So in my opinion, I would say when you talk about artificial intelligence, sometimes we should be also concerned about natural stupidity. Okay, natural stupidity is more dangerous than artificial intelligence. We write the code, we have been using, we use the algorithm, we use the data, we are using them correctly. Okay, that is, as I said, they have to be transparent, operation visible to user, printable, auditable, reliable, perform as intended. They should be recoverable. Even Satya Nadella says the most critical next step in our pursuit of AI is to agree on an ethical and empathic framework for its design. IEEE has come up with several interesting standards and ethical aligned. This one for different types, even including the issues of cyber security and all the things, how AI can handle these issues. And it is very much possible that AI may itself commit certain acts which may be classified as cyber crimes under various jurisdictions. If that happens, how has artificial intelligence to be treated? Okay. This has to be also regulated. As Elon Musk says, nobody likes being regulated, but everything, cars, planes, food, drugs, that's danger to public regulator. AI also should be regulated, but you should not stifle it so much that really it's the interesting development, creativity is stifled. Okay. The policies, the standards, benchmarks have to be properly designed. The design philosophy must be such that it ensures security against external attacks, and the current educational paths, educational the syllabi, curriculum, etc., should be properly designed. And as we said, this is in a multidisciplinary field like computer science, social, behavioral science, ethics, biomedical science, psychology, economics, law, and policy research. It is not the cup of tea of only electrical engineers or computer scientists. It is a multidisciplinary field involving several of these. India has come up with a responsible AI strategy like Centers of Research Excellence in AI, International Center for Transformational AI. So there are certain bold predictions. By 2023, AI techniques will be primary method for significant discoveries. Hopefully by 2025, the first national or subnational government will ban human-driven vehicle. And beyond that, AI will demonstrate creativity by producing maybe a blockbuster film. What is really missing? I'm coming towards the end. More autonomous learning, that is unsupervised learning. We should be working, discovering the underlying causal factors, okay, what causes what, model-based reinforced learning, which extends to completely new situations, unrolling powerful predictive models which can help reason about rarely observed dangerous states, sufficient computational power for models large enough to capture human knowledge, multiple time scales to handle very long-term dependencies like language learning, translation, real-time translation and all that, understanding the languages and solving, generating, recruiting enough world knowledge, common sense, large-scale knowledge representation, allowing one-shot learning, and discovering new abstractions and explanations, compiling previous observations. There is an interesting book by Professor Max Tegmark, Life 3.0, Being Human in the Age of AI. He's a professor in physics and AI at MIT. He had a book, Life 1.0, 2.0, 3.0. There are a lot of interesting issues discussed. The interesting facts are we invented fire, repeatedly messed up, then invented fire extinguisher, fire exit, fire alarm, fire department. We are responsible. Just as most chemists and biologists have no interest in building chemical and biological weapons, AI researchers have no interest in building AI weapons. The fear of machines turning evil is another red herring. The real worry is not malevolence, but competence. A super intelligent AI by definition is very good at attaining its goals, whatever they may be. So we need to ensure that goals are aligned with others. So an ultra-intelligent machine is the best invention what need can have, but they should be aligned with us, keep it under our control. So to conclude, a framework is needed to ensure that AI behavior is safe for humans and implemented through a set of logical constraints. Relevant professional ethical principles should be practiced. Research efforts must be concentrated in implementing regulations in AI that are updated in a continual basis, and more work needs to be ethical AI. Okay, so we shouldn't be worried about such a scenario. This should not be the concern. As long as we develop algorithms, techniques, as I said, we should not lose sight. Natural stupidity is more dangerous probably than artificial intelligence. Okay, thank you very much.
Thank you very much, sir. Thank you very much. I mean, I don't think that you set the tone for the conference. Actually, it cannot be better than this. So I mean, we don't have much time to take questions, and probably it's not also customary to take questions in the inaugural keynote talk. So, sir, we thank you for your colors of AI, your strong AI. I mean, what not actually? You spoke the genesis, you spoke the current trends, you spoke about the futures, you spoke about the danger in the AI, you spoke about everything, everything. I mean, I'm pleased. I mean, I feel honored actually to listen to this talk. Sir, we thank you very much, and let us give a big hand to Mr. Patnaik.
Thank you. If there are any questions, you can send me mails.
Yeah,
okay,
we'll
you have my emails.
And you are
The
there in this
participants.
conference till tomorrow evening, and if there are some questions, we'll definitely take it up.
No, they can also interact. Okay, thank you.
Yeah. Professor Sethi, over to you.
Sir.
And I request the audience that although we have a tea break, let's have the tea during the presentation, etc. The next speaker is already online. And let's start the next presentation. Professor Sethi, please take over.
Thank you, sir. Thank you, sir. I request Professor Sunil Kumar Tripathi to take over the charge of this next session of the yes. Sunil sir, present. Sir, Sunil sir.
Okay. Thank you,
Okay, sir.
Professor
Take over
Sethi.
the charge, sir.
Okay. Thank you. It's now time already we are late. Already we are late.
So,
Let me invite Mr. Sahasraram Namam Subramanian to present his keynote speech. Before this, let me introduce Mr. Subramaniam. Mr. Subramaniam holds a BS degree in electrical engineering from Copenhagen University and a MS in operation research and MS in computer science from University of California, Berkeley. He is the CEO of Cognitive Mobile Technology Private Limited, innovated many machine intelligence, machine intuitions, and estimations techniques for elevators, generators, locomotives, aviation, construction equipments, industries. He was CEO Snowwood in Infocom Technology. He was the chief consultant for WMX practice at Tata Elxsi, chief consultant at Arosur. He was the chief technology officer of Converse Lab Corporation and led the company's efforts to produce its Max-G product, allowing 3G type services over existing GSM networks and handsets. Prior to Converse Labs, Mr. Subramaniam was head of the Telecom Competency Center for Cognizant Technology Solutions, India. Prior to his involvement with the Telecom Competency Center, he was with IBM TG Watson Lab. Mr. Subramaniam is the Vice Chair with IPTC Regional Secretary for IEEE ACM Transactions, Asia Chapter, and a former advisor to the Board of Directors of Innova Telecom and Ostris Telecom. He is also former Vice Chair of 3G Span WG3 and IEEE elected fellow for 1999 and a fellow scientist for the Hypercube project at ICMIB. Now, I request Mr. Sahasranamam Subramaniam to deliver his keynote speech. Mr. Subramaniam, please. Are you there, Mr. Subramaniam?
Srinivas, you allow him to share the slides.
Okay.
You stop this presentation.
Okay. Mr. Professor Sethi, please allow Mr. Subramaniam to share his slides.
sir, no presentation is available, sir. Mr. Subramaniam can start the presentation, sir. No presentation is available now.
Mr. Subramaniam, no presenters are there, so you can now share your slides.
Srinivas.
Sir.
Srinivas,
Sir,
can you allow this presentation? Actually, it's not present. Okay, let me see.
Sir, no presenter are available now, sir. No presentation will continue, sir.
Okay, I will disconnect from here. You can join from here. Okay, yes, I can do that. I can extend the presentation to you. Yeah, please. Just a minute, hold on, please. He's not able to share the presentation. I'll do it now. Escape. sent it? Yes. Yeah, it should be just a minute.
Repeat, sir. Sir, just mute your phone, sir. Yes, sir. Thank you, sir. Thank you.
You can sit here and do this actually. It's in cloud. Yeah, it will download it. Yeah. Hold on for a minute. Actually, there is some issue with the sharing of the presentations.
Yes, sir. No issue.
Srinivas, just hold on for some time and download it. Yeah. We've tested it. You're still not able to just try there also. I'll just see.
Yeah, what I'll do is I'll just quit this for a moment.
It's not downloading also. It's not connecting.
One
Yeah.
second.
It is taking time to download also.
Yeah. Your entire screen. Allow.
Yeah. Is it allowing now?
Yes.
Oh, okay. Then that's much better. Yeah. You can go. Sound is there? Sound you have unmuted?
Hello, everyone. Can you hear me?
Okay,
Hello?
it's
It's audible.
It's audible. Okay, thank you for that. Okay, I'm Subramanian Sahasranamam, and thanks for inviting me to this conference. And it's my pleasure to present our product, which we have recently deployed in some of the Asian markets and some of the European markets after certain tests and government approvals, like the FDA's and the Mexican government approval and the Japanese government approval, Indonesian government approvals, etc. Okay, 1 second. Yeah, so I think now you're fine. So we have developed a iScan, and so our company is CIMIC, and we are based in Munich. In fact, a little bit outside Munich in a place called Stoffkirchen. And this company is a 38-year-old company specializing in RF devices, sensors, optical sensors, and etc. And we have given a lot of optical sensors to various different optometric companies, and we write software for them. And we are into sensor computing, starting from invasive and non-invasive sensors is our goal. When the COVID really started, prior to the COVID-19, I just want to give a small history. The history is when there was a problem, there was a very specific problem for the childhood where they have to detect epilepsy based on the vibration of the cornea. How does the cornea vibrate? And so that was our first project that happened like almost like 12 years back. And owing to that, we were doing a lot of various different optometric calculations and everything. So based on that, we were successfully able to achieve a COVID-19 rapid testing, and which has been used by certain governments. So it is 97.5 with specificity and with sensitivity. So I'll go to the next slide. Yeah. So how does this work? So it's a cloud-based software. So we do it as a SaaS model, where this is we have an app which is in a smartphone, which is an iPad and Android, and we also have a web-based. So if you have more than 12 megapixel camera or higher, and with a reliable access, network access, you'll be able to scan. And so how does it work? We captures individual's eye image by the iScan app, which is in the store. And if you do not have a phone, then we also support a web-based operations. And so we provide a web interface as well as APIs. And then we also have like multi-scan setup for capturing multi-eye images from one thin client or one workstation. So this is more specific to the airports. And this is our setup is. So we have like multiple webcams with a thin client, and there's a cloud. And the eye is being scanned, and based on various different patterns, what we scan from the eye, we basically scan the sclera and the conjunctivitis. So these are the two layers, which does not have blood supply though, but it runs blood vessels through them. So basically we scan those and then we send it to the cloud server. And the operation of the system is follows. The CMYK eye scan takes a frontal image of a human eye. And we start with the left eye because the machine learning was able to provide more and more samples with the left eye rather than the right eye, and delivers results in 3 minutes time, approximately 3 minutes. Sometimes it takes less than 10 seconds, sometimes it takes all the way up to 3 minutes. Yeah. So after that, the COVID-19 infection, if the person is infected or not, is being taken. We've been asking him to do a deep breath, and so that if that that creates a, when you normally take deep breath, the eye dilates. So then we take the picture of that. And all our tests, due to legal restrictions, were only 8 and above. We were not allowed, and we work with certain universities in US as well as in Germany. They are public universities, and they didn't allow us to go anything more than less than 8. So all our samples are more than 8, and it goes up to 80 to 90 years old. The contact lenses would not affect the operation because we take only the sclera and the conjunctivitis, and that's how the system is. By touching the photo icon, the CMYK eye scan app, the system collects multiple images. That means it takes a burst of images, and so it's not just one image. So it takes a burst. So we have a special way of capturing the eye. So we use this image so that always we use an algorithm called as the best fit, and we superimpose them in order to obtain a clear, in order to have a very clear structure and of the eye. So what do we do? The pink color pattern has been analyzed. So there are various different pink colors. In fact, there are millions of pink color you can find in the eye, and the pink hues over than 2 million. So which will indicate that it has conjunctivitis. So what do? Is we take it as an YUV image, and this YUV image is converted into a grayscale, and we have a grayscale differentiation mechanism. And using this particular mechanism, we are able to come out with a possibility that this person might have the 19 infection based on our, basically on our assisted, learning systems, as well as enforced assisted learning systems, which we have done it with optometrist and with optical instruments. So now we have also come up with other viruses also, like dengue and also the Zika virus. So that's also CMYK eye scan can detect both, and currently it's a trial stage. Okay, so initially with the help of the university, we were able to take up to 70,000 individuals and who were deceased. Okay, we have taken 1.2 million participants, in which 70 individuals were deceased with COVID-19, and almost we were able to get 97% collection out. In another verification which we did in Europe, we collected up to 81,000 samples. These were the people who are crossing from the Czech border to the German border. So there's a check post. So the way we tested is, we take a scan of the eye, and it is immediately that's the LHS, that's the left-hand side, and the RHS is, we do an RT-PCR test, and the RT-PCR test, and we also do an antigen test. So end of the day, the three are studied together. So even though RT-PCR is called as the benchmark, we validate, and based on that, we were able to see whether our eye scans, how successful our eye scans were. So initially we never got 97, we got less than 1%. We started with that. That's what we started with, almost like in 2020. The verification started in February, and when the Europe reached its peak during, and there was a lockdown in June, July, August of 2020. That's when the Europe was in complete lockdown. So still the workers had to cross from the Czech border to the German border. So that was our primary test case, which was done by an institute called as DRK, and which is supported by the Fraunhofer University, as well as the Maximilian University, which is in Garching. And with all these connected together, we did our test. And in 2021, yes, we had to take it to various different governments for approval. And like there's a Bosch Institute, which is in Germany, and in the US we have an FDA. And we have supported, and I would say that allied institutes all over the world, including the Japanese and also the Indonesian, the Thai institutes. So we are almost in the process of getting verification from them. For some places, yes, we have the approval for going through an extended test, and for some places it is still in the process of approval. Okay, so we call it as a pink eye syndrome. This is what the Roski Institute of Optometry, which is a part of University of Southern California, they came up with, and we took this as the lead, and from this, we took it. We also call it as the pink is a scar. That means even after an infection, we are able to find out that there is a possibility that this person might have had an infection, and by this, we call it as a pink scar. Okay, this scar is not visible to human eyes. So that's the pink hue which has been left by the virus, and it also finds out the asymptomatic. It also finds the virus in asymptomatic people also. We are able to see if this virus, like how long this virus affected a person, like up to 6 months of infection, the person is cured, but up to 6 months of infection, if a person comes and takes a scan, we are able to identify whether he had infection or not. So this is one of our study. If the viral content is high and the antibody content is low, within 1 day after the infection, we get the point. And this is with a biological study or with an optometric study associated with our scan. So it is not purely our scan. So we have this optometrist and the antigen and the RT-PCR and the biological researchers from the university. So they give the results and we compare this with our scan. And second thing is with approximately equal viral and antibody load, which is like 3 days after the infection point, so we were able to find out if the viral content is low, but the antibody content is high. So within 6 days after the infection point, we are able to identify. So this is a infection acquisition cycle, which we did it along with the universities. And now we are able to identify different kinds of mutations during the pink hue. Again, this is not completely approved. We are not allowed to give the mutations at this point, but later after our FDA, I think we'll be able to tell the mutations. What are the different mutations, and we can label those mutations. So we have our own assisted neural network, which has multiple perceptrons, and these perceptrons have a differential Gaussian capability. So using which we are able to see in a Gaussian map, we are able to plot those strains, which are nothing but the different mutations. And next to the, we are supposed to, I mean, we currently, during our test stages, yes, we are able to tell the mutations because that's very essential for our testing. But in our commercial releases, which we have released, we are not allowed to tell the mutations. And okay, we found the Omicron strains during 27 November based on our test. And the COVID, yes, the pink appeared very, very pale. It was sometimes initially for this particular strain, we tested even negative, but later we were able to identify this very, very weak mutation, and the pink hue was very, very pale, and we are able to identify it now. And during these cases, we also found out that the infection is very mild, and most of them are asymptomatic cases. So, so what's our data processing limit today? So we're able to process up to 4 million scans per second at a stroke. That's our cloud capability. And our testing time is 2 to 3 minutes max. So within 3 minutes, you should get a report. And there is a QR code option, wherein which a person takes a picture, and he does not get the result, but he gets only the QR code so that it becomes foolproof. And this is again a government regulation. And we also did our test in the Olympic Scan Committee also, and which our result will be there on the website pretty soon. And so here, all the data we have an AI, Emily, which this is our system. Emily is our system, which is proprietary to CIMIC, and this does the entire data processing for this. So this is a deep learning system what we have. So the digital reports can be stored in user devices and sent to the stakeholders and health authorities based on the workflow the Center for Disease Control and Prevention asks for. And we are also trying to have like geotracing, like where do we find the highest traces. And we also have geofencing functionality saying that which has been given to security agencies, where these security agencies scan and give reports about, okay, for example, in which railway stations or which metro stations, there are more, there are more infections, because ultimately they need to quarantine them or they need to send them to some hospital, etc. So we also send these reports. Again, all these are based on the governmental requirements. And well, we have a natural language processing, which is very, very important in this case. So the entire system can be commanded using the voice, so which is an NLP process. So it can speak multiple languages in this case. Since this presentation was more mapped for an Indonesian audience, so it shows in Indonesian language or the Japanese or it can process many other languages. So a customer can simply say, okay, what's the infection rate? How many infections are in this particular area? It's done by the voice. So it can take any language. It can take most of the languages as voice input, and it can process it. And well, since we are in EU, the GDPR conditions are fully met. In US, there is apart from the HIPAA Act, there is also Center for Disease and Viral Research, which is a part of the Washington Initiative for COVID. So we have to adhere to their results also, so that we do not take the person's entire face. We should take only the sclera, and we should block the cornea or the iris, which can be used for some security clearances as well as security authentication. So we have to make sure that we do not take it, we block it, and only the sclera has been taken, or the conjunctivitis is taken into account. So we are compliant with the entire EU data protection of the GDPR conditions. Personal data is again is not taken, and all the images are encrypted, and finally a code, a random code is being processed, and the result is being inserted in a random code and sent to the server. So literally an eye image does not go to the server. So that's the objective. So I would like to play how this works. So this is sort of a live demonstration. We have also been covered by Reuters, BBC, and CNN after we did the first test. So if you can go to the Reuters in the YouTube and you can just say Reuters and CEMIC iScan, you will also get a news coverage about our first test results. And so what are the key features? Number one, non-invasive, no touch of human body at any time. Hit rate we have produced based on the results, based on the sample size, is almost 2 million and is 97.5%. And we have taken people who regular conjunctivitis as well as COVID-based conjunctivitis, and then lung disorders, non-COVID lung disorders. We have taken multiple possibilities, and then we came up with this particular hit rate. And these are all from universities, university medical schools from where we have taken it. And the test results will be available in 2 to 3 minutes after image acquisition, and then 4 million scans at a blow. That's our server. So there is no chemical waste generation, and this is used in airports, in public transportations. So it's both voice and text based. It can be customer desired voice. And as you see, this can also, tell your pulse, your body temperature, and your blood pressure. That's what we have added, and this has been approved for us to tell by various different test results and by the approval authorities in Europe, part of the Europe and in US. So currently capturing and reading it of all current and mutations are allowed. We can read it out, but it's not allowed. I'm sorry, it's not allowed by the government because again, we have to do a lot of tests. We have to go through a lot of tests, and it may take us 6 months or 8 months time till we get to get the approval. And we are able to get a quick classification of the viruses. And the infection detection scale, as I mentioned before, is 1 to 6 days. Infection detection possibilities up to 6 months in the past. And possibility of interrupting infecting, is post-haste. Tamper-proof data processing, because we do not send any image to our cloud. So it's more the grayscale numbers which we send. And owing to sterile computing, we have the highest data security which is available. And we are trying to do this. This is some of the things which we are adding, which is skin cancer, which is focused on the mole or some kind of black patch, which is available in your dermis skin, and you can take the picture of it. And we are doing test for it's currently under the test. So we'll do many things such as bile disorders, diabetes, liver diseases, lung diseases, etc. So this one just not eye scans but other scans too. So we are very close to Alzheimer and in Parkinson. Yes, we're pretty close to that, and we will soon get an FDA result before the first quarter of 2022. So, in general, all viruses leave scars. So here, even like a herpes leaves scars. All we know that even after the virus is dead, those scars remain. So that's how the calcium receptors, tend to. I mean, we are also able to predict strokes and heart attacks. Soon, we'll be releasing this based on calcium receptors analysis. So this is something more we are trying to do in this thing. So CEMIC RF, our company, it's from 1986. It's an independent owner-managed company, and it's initially in the RF and microwave technologies, and subsequently it's in AI and SAS processing. And we have developed our own CEMIC Emily, which is our proprietary self-learning technology specifically for healthcare use. So this is much compatible with the languages, business, trade, goods, and health systems worldwide. So this is where we are. So I hope this presentation will be shared to everyone. Plus, feel free to contact us and send your emails, your queries, your questions, and we'll be much glad to answer you. Thank you so much for the opportunity, and you all have a nice day.
Okay. Mr. Subramaniam, is it finished? So this nice presentation on the Epic CEMIC ISCAN device may now be open for questions from the audience. Very quick, short questions are invited.
Okay. Uh, thank you, Professor Subramaniam. And now, next session is delivered by this Professor Amit Kumar Mishra. Is currently a full professor in the Department of Electrical Engineering at University of Cape Town. Before Cape Town University, Amit has worked in Australia and India. He did his PhD from this University of Edinburgh. His area of interest includes radar system design and applied machine learning. He has successfully supervised number of PhD students and having a different project exposure during his professional periods. Thank you, Professor Amit Mishra, and I request you to deliver your talk, sir. Professor Amit Mishra, I request. Hello. Hello. Hello, Professor Amit.
Hey, somebody, he's muted. He says he's muted. You have to unmute him.
Yes,
or
sir.
something. Yeah. You unmute him.
Yes, sir. Yes, just one. Uh, Amit sir, you just unmute your at your end, sir. Hello.
Okay, yeah, now it's working. Thank you very much, Nivasji.
Sir, welcome, sir.
Yeah. Thank you, Professor Amit. Yeah.
Thank you. Let me try to share my screen again.
Yes.
Please do that.
Yeah. Is it visible?
Not yet. Not yet. Now coming.
Just
Now coming.
Let me enter the full screen mode.
Fine.
Thank you, everyone, and thanks, Professor Udgata, for inviting me to share my experiences with this interesting crowd. As Professor Srinivas told, my talk would be on bio-inspired methods for sensing and instrumentation. I'll very briefly tell a little bit more about myself, and then I'll jump into bio-inspired sensing. In total, we shall discuss almost 4 different bio-inspired techniques. As Professor Srinivasan told, I grew up in Bhubaneswar, then did my undergraduates in REC Rourkela, following which I worked in DRDO and Wipro for some time. And then I started my postgraduates and PhD in University of Edinburgh. And then I was in IIT Guwahati as an assistant professor, following which I spent some time in Australia. And since 2011, I have been in Cape Town, in the University of Cape Town. Right, my areas expertise, I like to think myself as an innovator, educator, and researcher. As Professor Vasan told, mostly I work in the domain of radar and telecommunication system design and signal processing, sensor design, which nowadays are called IoT, which I don't exactly agree with, but that's fine. Applied machine learning, and in core machine learning, I work a bit on cognitive machine learning, i.e. brain-inspired machine learning. In addition to that, we also work on innovations around solving societal needs. Without further ado, let us go to the fast bio-inspired sensing method, which I called as application-specific instrumentation, or ASIN. The background to this is this way. So a few years back, I saw this paper in Nature, which is about bats. And the reason I was looking at these papers is because we're trying to see what can we learn from the way bats process signal. Because bats are very similar to radar. They also transmit and receive signals, and based on that, they do echolocation, they recognize things, they navigate, and all those things. In this work, it's quite interesting. They have studied one kind of bat, which is a pollen-feeding bat. It feeds on the pollen from different flowers. And they took one of the flowers that this bat visits often. Like this flower is quite predominant in its ecosystem. You can see that they have taken 3 different flowers. In one, it has fully bloomed and it has got proper nectar. In other words, if the bat goes to this flower, it can get some good food. The second one has not bloomed at all. So if the bat goes there, it may not get enough food. It will have to also spend more energy to open the flower and all. The third one, the flower has bloomed properly, but they have replaced the nectar with water. And you can see that the bat goes to the first flower. That's the only case in which you will get some food. And what you see below are the reflections of the bat's signal from these 3 different flowers. Only in the first case, the case in which the flower has fully bloomed and it has got real nectar, it gets quite a high signal return. What does it mean? It means that the bat does not do a lot of processing in its brain. Its signal has been designed so that the signal kind of does a lot of recognition in itself. So because of this masked signal design, the bat does detection and recognition at the same time. In other words, when the signal is high, like higher than threshold, which is mostly a detection problem, it also implies recognition because the bat is only interested in very few things. So that is why it has evolved together with the flower, of course, to make this arrangement so that the flower structure and the bat signal, they have evolved together to create the situation in which detection and recognition happen together. If you think, this is very different from what we do, like we engineers do. In engineering and science, we design instruments which are very generic. So they can be used for all kinds of purposes. And they create signal, and mostly our signal processing chain has got 2 major parts, detection and recognition, or detection and estimation. Can we design something that is like the bat, in which case it is highly specific to an application, and thereby can we make the whole system cheaper and simpler. Now, before going there, I'll just mention this interesting word for two things actually: co-evolution. Co-evolution in which the two species, the bat and this flower in this case, have evolved together so that they have a matched structure and a matched signal. Hyperactivity I'll come to later actually. Let us keep that for later. This is a conventional man-made sensing paradigm. There is an environment, we have got a sensing platform, we have got a computational platform, it can have statistical signal processing, it can have machine learning as well, all sorts of fancy techniques. Based on that, you take an action. It's mostly highly linear. So that is one-to-one correspondence. So one thing goes to the next. There is hardly any kind of feedback. Compared to that, what happens in nature, I call it circular sensing. There's a lot of feedback. So there is feedback depending on the situation and depending on the task. There is feedback from the computational platform to the sensing platform, so that the sensing or the sensor's characteristics can be changed on the fly. Similarly, depending on the action, it can also give some feedback in which the computational platform can take on the fly reactory actions and thereby change the sensory platform. Lastly, depending on the action, the environment also changes. That is through co-evolution, because depending on how the bat is behaving, the flower also changes. That is something that we don't exactly are able to do in man-made systems. But if you think, there is a lot of work that is going on in trying to make sure that we can have enough feedback in between sensing platform, computational platform, and action. And one of the things that has really made it possible is the there is a lot of development in the domain of software-defined sensor, be it software-defined radio or software-defined radar. So those things have enabled to make sure that we can change the characteristics of the sensing platform on the fly, depending on the requirement. Now the last bit, that the bit that the nature implements the co-evolution, we can to some extent implement that. And that is what this fast bio-inspired sensing technique is about, in which instead of letting the environment change itself, of course that will not happen, let us study the environment and find out what are the properties of the environment, and based on that, we design the whole system. So the instrumentation design happens with a very deep understanding of the application, and that is what I call application-specific instrumentation. The fast demonstration of this principle, and of course, when I tell about the demonstration, the exact principle of working will become more and more clear. And of course, if there are questions, we can take those questions at the end of the talk. So this was a project I did when I was in IIT Guwahati. It was sponsored by Honeywell Technologies from Bangalore. During that time, ultra-wideband bandwidth was released for public usage, as long as, of course, your transmit power is below -40 dBm. Now, Honeywell Technology wanted to investigate if they can use this new set of sensors in detecting the volume of sludge in big oil storage tanks. So these are crude oil storage tanks, and crude oil has, of course, got lots of impurities, and with time, these impurities settle down as what they call sludge, the black thing you can see at the bottom. Now, sludge, of course, as you can imagine, has got a higher concentration, higher weight than oil. So it puts more pressure on the wall. So when the volume of sludge is beyond certain limit, they should do regular maintenance and clean the floor of the tanks. And they wanted to see if they can find the volume of sludge using ultra-wideband sensor. Now, if you think of the problem, the obvious way would be to use the ultra-wideband sensor, almost like a label sensor, and try to find out the level of the sludge at multiple points, and thereby create a profile of the sludge. And because you know the circumference of the tank, so you know the surface area, and if you can find out the profile, then you can find the volume. That's obvious. Now, finding the profile can be possible by two ways. Number one, either you have lots of sensors on the top, or you move a sensor slowly so that it traces and tries to collect the data from different points, creating. Now, this is the linear sensing paradigm. What I thought that, okay, in this particular case, finding of the profile is an intermediate step to find the volume. The customer doesn't care about the profile structure. They only want to know the volume. If that is the problem, can I design a sensor which can directly give me the volume instead of finding the profile? And if I can do that, can I do that using very less number of sensors? So in this particular case, we tried two paradigms in which we had one transmitter and one receiver, one at each end. In the other one, we had one transmitter in the center and two receivers at two corners of the tank. We collected the data and created a database of the volume and the profile of the sludge and the respective measurement. So we basically have transformed the detection and estimation problem to a problem of linear regression problem. So the idea is that you design this algorithm, input would be the measurements from the radar, output would be the volume directly. You don't care about the sludge profile. Now, it was quite an interesting idea, and we didn't know if it will work, and interestingly enough, it actually worked. And we could get regression coefficients up to 0.95. That's almost 95% correct prediction of the volume. And that was the first success of this idea of application-specific instrumentation.
Hello.
Second, hello?
Good afternoon.
The second application of ASIN principle was in design of this interesting sensor, where we designed a fake medicine detection system. Now, you might have seen different news articles at multiple times where they tell about police has captured this huge mafia or huge lot of fake medicines. And fake medicine is a big problem in developing countries, and so much so that in 2019, WHO estimated that the total volume of fake medicine business is to the tune of $10 billion, and that's a lot of fake medicine. And you can imagine the effect is quite detrimental, because if somebody is sick and you give fake medicine, definitely is not going to help. It might actually kill the person. So, and to detect if a medicine being administered is genuine or fake is actually extremely difficult, because the easiest way or the accepted way is to design a spectrometer or a spectrogram, and spectrograms are quite costly. And the cheapest thing I have seen in literature is Raman spectroscopy. So they put the things in Raman spectroscopy, find the chemical constituents of the medicine, and from that they try to find out if it is genuine or fake. Now I asked the same question. Do we really want to design a system that can recognize or study all kinds of medicines? The answer is no. For somebody, let's say an Asha Didi who is in the ground in some village, she has been given some medicine. Let us say she has been given azithrol, and she wants to give azithrol to a patient. What she wants to know is this medicine that is in her hand, is that azithrol or not? It's actually a yes-no question that we have to answer. We don't have to do the whole chemistry of the medicine. If I can answer this yes-no question, that actually is very useful. So for that, we try to make things very, very hacky and very cheap as well. And as you are telling, so Raman spectroscopy has been shown to be quite effective. So what we did is that, and of course, Raman spectroscopy happens mostly in infrared. So we wanted to see how can we generate infrared
signal. And so we picked up a tungsten filament bulb because, you know, the tungsten filament bulb gets quite hot, which means that it does emit a lot of infrared radiation. With that, we diluted the medicine and put it in a container through which the light will pass, and then there is a slit, and then that light gets reflected on a DVD drive. And now the rainbow you see on the DVD drive when you reflect any light, that actually is the spectrogram, a very crude spectrogram of whatever it is going through. Now we captured those rainbows, and those are basically our very crude spectrograms of the medicine. Now the question is, how do we measure the infrared part of the spectrogram? Because infrared cameras are quite costly. So, but then we thought of a quite hacky way. You know, if you buy a cheap webcam, so those cheap webcam sensors are actually very sensitive to infrared, and that is why a cheap webcam will have an infrared filter on top of that. So we took a cheap webcam, broke it, and removed the IR filter. Now that thing could sense infrared to some extent. So basically we collected a lot of data. Data means we put the medicine, switched on the on the bulb, and collected the this crude spectrogram. And next, we just have to see if there is a new spectrogram and we know which medicine we're looking for. The answer we have to give is yes or no. So you think it's a machine learning problem. But if you make it a multi-class machine learning problem, you need it to become more powerful. It has to have a lot of data, and all those things will come into picture. But if you're only trying to make it a two-class classifier, which it is, the requirement is to give a yes-no answer. And then what happens? The accuracies are much higher. It's much simpler. The unpredictabilities are much lower, and that's why you can see that we could achieve quite tremendous amount of correct classification percentages. We tried for 4 different medicines, and these are the accuracies we have got. We tried 2 levels of testing. In one level, we tried to detect true medicine versus fake medicine. In the other one, we tried to dilute the medicine, because these are the 2 different ways people do counterfeit medicines. In one, they just give a placebo. In the other one, they actually dilute the main component of the medicine quite substantially. So we tried to do the dilution as well, and that also we could do some, we could predict with quite good accuracies. So that was the second experiment we did using this principle of application specific instrument, again, quite successfully. So the idea is that if you have a problem and you exactly know what you want to find out, and that's why I try to spend as much time as possible in what they call in the problem space, try to understand the problem. The better you understand the problem, the easier it will be for you to answer that. You know, as they also say, when you get a question in exam, try to understand the question. The better you understand, the more better you can answer the question. Now let us come to the second biosensing or bio-inspired sensing paradigm. I call it signal mapping. Let me give some quick background. So I mentioned this word hyperacuity before, right? And hyperacuity is basically, sorry, let's not go there. Let me tell you this background of this one. A few years back, I was in a conference in which one of the plenary speakers was the curator of the museum in Paris. And in his talk, he was talking about the art in rainforests, created by nature. And in that, he was playing the sound of rainforest. And as you can imagine, rainforest is the richest biodiverse place in on the earth. It's full of different kinds of animals, insects, birds, plants. Everything is trying to create some kind of noise. And so it's full of different kinds of noise. So, and his question was that in all this combination of mixture of this richness of noise, how do individual species communicate with each other? Now,
He didn't give any answer, but when I looked in internet, did some research, I found that there are two hypotheses. None of them have been actually validated, but one of them says that every species, when they emit any sound, when when they're trying to communicate with their fellow species mates, they actually code their signal. It's almost like CDMA. It's pretty fancy. And that's how the receiving part, like the other animals, they can recognize and they can decode and understand what the other species, other guys talking. The other hypothesis is that even though there are lots of sources of sound in rainforest, together they create this kind of orchestra. Like if you have gone to orchestra, if you have got some musical training, you know that, given any song, like if you have got friends who are into classical music, you play them any Bollywood song, they can tell what raga it is, right? Even though the song is a constituent of many different sounds, many different musical instruments, still they can recognize the raga. And the second hypothesis, like something similar, even though the total sound is a mixture of so many different kinds of sound, the trend is what matters. And different species have learned over millions of years of evolution to recognize these different trends. And that is why you take a species from its own ecosystem, it mostly will fail miserably. So what they do is that instead of trying to detect each signal, they try to find out the trend. And I thought, okay, something similar to rainforest is actually happening all around us, because we are now undergoing this telecommunication revolution. Look around you and you'll see like so many types of telecommunication signal bombarding on you. You have also got FM radios and dish TV signals, then your 2G, 3G, and all kinds of signal is around you. Can we not just design a receiver which receives these signals and doesn't try to exactly understand the signal? Rather, it tries to look at the trend, and from that tries to detect or recognize certain events of interest. And I call that communication-based sensing, ComSense. And instead of trying to do for every kinds of transmitter, I try to start with focusing on one kind of transmitter. And those days, the major telecommunication standard was 3G. So I focused on 3G communication signal. And if you know a bit of digital communication, you know that digital communication relies heavily on channel equalization. In channel equalization, part of the transmitted signal is already known to the receiver, and that part is used by the receiver to estimate the properties of the channel, and from that estimation it tries to correct for the unknown parts of the block of the signal is transmitted. I said, okay, let us use the channel equalization block in which it tries to estimate the properties of the channel anyway, and from that estimated properties of the channel, can we estimate some events of interest? As you can think, let us say in GSM, sorry, no, not GSM, in 3G, that's GSM actually. In 3G, the number of bits that are carried for channel equalization is 52. So from 52 numbers, you are trying to estimate everything that lies in between the cell phone tower and your phone. That is impossible. It's impossible to find everything clearly. But then if we flip the question, now instead of trying to find everything, let us try to find only one thing. And let us collect signal about that one event a priori, keep that as training signal. And when it's operating in the test mode, we compare the new signal with what we have before. And if it matches, then maybe we are having the same kind of event in the new scenario as well. So that's what we did. We call it ComSense. And the status is that because it's a very interesting new idea, we could get a patent of this thing. We tried it both in GSM, and in 2 years, LTE was all over the place. So we tried both with GSM and LTE. that actually led to 2 PhDs, one in GSM and one in LTE. And most of our demonstration was done using a cheaper SDR board. We didn't use the ATAS user board because it was a bit too costly for us. We used Blade RF, that's much cheaper and with the same functionalities. Let me, yeah, so that's the standalone device we created using Blade RF. So the right hand side board is the Blade RF with antenna, which receives the signals and it does the demodulation part, and it finds out the channel equalization part, and it just demodulates and sends to this part. And this is the computational platform with Raspberry Pi, and that is running a GNU radio. In the GNU radio block, it finds out the channel equalization block, finds out those information, and it also has got stored data about the training from the training phase, so that given a situation, it can automatically detect if that is happening or not. In fact, we demonstrated, you can look at this YouTube video where we demonstrated this system working to detect human beings behind wall. So, because if there is no one behind the wall, that is one situation. And if that situation changes, that is a change. And our system can actually detect that quite easily. And one thing that we were asked by many reviewers when we submitted papers was, what is the resolution of this system? Now, resolution is a tricky question because resolution is mostly attached to conventional instruments where we are trying to detect everything. In this particular case, resolution had to be redefined. So we redefined resolution based on 2 different matrices. In one, resolution was redefined using Neyman-Pearson principle. In the other one, we redefined resolution using camera bound as the measurement metric. And the table actually shows something very interesting, that this is for LTE comsense, so communication based sensing using LTE signal, and we are measuring the resolution at different distances from the user equipment or the receiver. You can see that as we move further from the receiver, our resolution actually becomes worse and worse, which means that if something is happening near to my receiver, I can detect that event with good confidence. If something is happening far from my receiver, I can't exactly tell what's going on. This is actually a good thing, because another question we are also asked by people to whom we demonstrated is that, there are so many things happening in between the tower and your receiver. How exactly are you confident that it is only seeing things that you claim it is seeing? Now, the good thing from this resolution experiment is that anything that is happening beyond 10 meters from the receiver don't exactly matter. So for our system, they are as if they are not out there at all. And that's actually a good thing because it doesn't depend on all those crazy amount of things happening in the distance. Let's not skip this one. This is just some other papers trying to show the diverse kind of applications we have tried to put use of this new sensor. I'll just leave it on for 1 minute so that you can read and see the kind of applications we have applied them to. The last one, of course, is the through wall sensing thing that I showed. I told that we have got the video. We have got it for sensing vehicles. In fact, the recent most work we did was demonstration of the system in finding the size of crowd, which would be quite useful in COVID situations where there are different regulations on how big a crowd can be assembled in certain indoor environments like a mall or a shop. Right. Let's go to the third biosensing, bioinspired sensing paradigm. So far we have discussed 2 of these things, and these 2 bioinspired sensing paradigms have been pretty well validated. Now we shall discuss few of the bioinspired sensing paradigms which are work in progress. So we haven't exactly got a lot of results, but we have got some good preliminary results. So the first in this one, the third biochemical sensing part, is something called WebCA. So it's a bio-inspired cognitive architecture inspired by weakly electric fish. Now, as I was saying initially in this talk, I was studying bats. So that was a while back when I was in Australia. Because the bats are very similar to radars, but there is a big fundamental difference. Radars use radio frequencies, whereas bats use sound waves. There is another species in animal kingdom which is exactly like radars, because this thing actually transmits or uses electric signals. It's called a weakly electric fish, and it is very different from the electric fish which uses electricity to stun you. So this actually uses electricity to do three things. It can detect things, it can navigate, and it can also communicate. And the last part is extremely important because there are a lot of groups in the world nowadays which are trying to develop integrated systems which can be used both as a radar and as a communication system. So it should be, we should be able to use it to both sense the environment and also communicate. And this fish has been doing it for millions of years. It uses the same set of sensors to do echolocation, recognition of objects, and communicate with its fellow species animals. Now, it has got one array of electric sensors. So using that array, it transmits, and again another 1D array of receivers it receives. So basically in signal processing terms, what it receives is a 1D vector. Now these are the major steps that happens in the fish's neurological system. And actually I should mention another interesting word called neuroethology. So neuroethology is the study of brain for these small animals. So what happens is that there is this one-dimensional signal coming from its receptors that is then transformed into three two-dimensional maps using different mappings. And those of you who have worked on convolutional neural networks, they can recognize that in CNN, something very similar happens. You use different kernels to map signal into different CNN layers. And that's exactly what is happening here. Again, it's not exactly convolution, but it goes through a processing and it is mapped to three two-dimensional maps. From that, it's again through mapping, one other layer of mapping is mapped to 12 two-dimensional maps. Now, this fish is a tiny fish that lives its life in deep Amazon or deep Nile River, where there is too much sediment, and because of which it has evolved to not use its eyes, rather use this fancy electric signal instrument. So it needs to deal with only a very few kind of things in its whole life. It doesn't have to read philosophical text or do something fancy. So based on that, over millions of years of evolution, it has learned that, okay, in this layer, these 12 layers, depending on which layer is high, certain event is occurring. Again, something very similar to what we have seen for bats. Detection and recognition happen simultaneously. And once this whole system has been trained, it just has to see, okay, which layer is highly activated, and based on that, take a decision. We tried to do something very similar, and I thought, okay, let's design an architecture which follows this same kind of pattern and try to see what we can do. So what we did is that this is the architecture we designed. Okay. Which is very similar to what you have seen. So there are convolutional layers, and based on that, we try to emulate the tectum, which is the decision-making part. and everything is fine. But one thing is very difficult to implement is that, based on what its higher brain recognizes, it can change these layers. So you can see that, that red arrow that is going from thallium down towards the TS layers, and that is where it can actually change the way things are mapped. And that is kind of a holy grail for in AI research nowadays, what they call top-down interface. So most of the AI systems have got a non-symbolic layer, which is mostly done using deep learning, and a symbolic layer, which is rule-based analysis of signals. Now, if on the fly it wants to change the non-symbolic part, the deep learning part, it is extremely difficult to do that. And that's what this fish does actually. And in our architecture, the first part is pretty simple, but implementing the top-down approach, and that is, if it wants to change things because it's in a different situation, how can it do it? So to just explain this thing, for example, imagine that the fish is going around navigating in its thing, and now it wants to use the same sensors to communicate. Because the sensors are the same, it has to change certain things. So it changes these layers, the TS layers, so that now it can do communication. Now that thing is extremely difficult. So we are now trying to work on that part. That is, how can we change the deep learning part or the CNN part based on a command from the top level? And what we have worked on so far is something that we called a a masking based deep learning control, in which, depending on the situation, we can change the mask, which will then change the performance, or the working of the whole deep learning block. So we have got a deep learning block which we can fine tune on the fly. And there are few other approaches of doing the same thing. Like one of the naive approaches is to have different deep learning blocks for different situations. That's very easy. Depending on what situation you are in, you just change the network. That's what the Google guys have done. But then it is extremely expensive in terms of computation and memory. What we have done, it uses the same deep learning structure and fine-tunes that for different applications. If we have time, I can tell about the details of that. But for now, let us stop it here. Let's go to the next one. As I was saying, I did some work on learning from human brain-inspired architectures. In that, those of you who have looked at the historical development of CNN might have seen that one of the major inspiration behind the development of CNN is the study around prefrontal cortex and the visual cortex. And the visual cortex processes data exactly like CNN in different layers, and with every layer the abstraction level increases, and from there, that's one of the major inspirations. So we thought, okay, let's look at something else in the brain, and we found this extremely interesting part of brain called hypothalamus. Now hypothalamus is the interface between sensory signal and the cortex. The cortex is where the perception happens, and the sensory signal sends the signal, and then hypothalamus does two main things. Number one, it tries to substantially reduce the amount of data that is sent to the cortex. And that's why you might have seen that many reports which say that brain actually can do classification tasks at a tiny fraction of the energy that conventional deep learning networks take. One of the enabling factor in that achievement of brain is hypothalamus, because hypothalamus substantially reduces the amount of data that goes onto the cortex side. Second thing that it does is that it tries to frame the data in such a way that the structure of cortex becomes agnostic to the sensor. Irrespective of what sensor data is coming, the structure remains the same. And that's another big research area nowadays. How do we design the perceptual architecture which is sensor agnostic? Because you get new sensors every year. In fact, every quarter you get new sensors with new abilities, new resolutions. How do you make sure that your overall AI system doesn't have to be changed every time there is a new sensor? And our hypothalamus actually does exactly the same thing. But we didn't go to that activity. We focused on the first one. How does it drastically reduces the data? Now, what it does is it resamples the data using a logarithmic sampling scale. Now, to demonstrate that, imagine, think when you are when your eyes are open, depending on what point you are focusing on, areas around that point appear quite crisp and clear. And the areas in the periphery of your vision, they're always very blurry, isn't it? Now that is because of hypothalamus. Hypothalamus actually makes sure that the data from your eye is resampled. Now, depending on which point your brain wants to focus, those points are sampled naively as it is, and the further you go from that point, your resolution frequency becomes much and much less, and that drop in sampling frequency happens in a logarithmic way, and that's pretty easy to do by what is called log polar mapping. So that's what we did. This is a Euclidean mapping, and this is log polar mapping. And our research question was, when we change the data through a log polar mapping, how badly does the performance of classification suffers? So, in other words, we took a very naive classification, it's almost like 101 of machine learning nowadays. We took the MNIST data of the digits. We tried to recognize them, first using the data as it is, and secondly, by taking the data through the log polar mapping. And as you can imagine, when you take it through the log polar mapping, you can reduce the amount of data quite a lot. So this is the result that we got. Let's just look at the plot on the right hand side. And in that, the x-axis shows the amount by which the data has been reduced. So you can see that with all the data present, you get something like 97.7% correct classification. When you lose 50% of data through log polar mapping, your performance is still 97 point something. Even with 25% of the data, you can still get 95% correct classification. So the answer is yes, of course you will lose performance, but you also are using much less amount of data. Now, depending on your problem statement, is your customer okay with lose some performance to gain on a much lighter and quicker process? So if the answer is yes, then they can use this one. So that was one of the results from log polar mapping. Of course, this is an ongoing research. The next we are trying to focus on, okay, it's easy to say that you do the log polar mapping around the point of interest. How do we find the point of interest? That is another big question that we are working currently. The last bio-inspired sensing paradigm I will talk about is optical oracle. Now, what you see in this picture here is the range Doppler plot that we measured in a harbor near Cape Town, and it consists of data from few drones that were flying around. And funny enough, when we are flying the drones, the seagulls always try to fly around it. So the data has got data. The sinusoidal things you see, they're basically either the drone or the seagull circling around the radar. Now, just looking at this thing, it's impossible to tell which one belongs to the drone and which one belongs to the seagull. And that's almost like Plato's caveman caveman's problem, where it's human beings are as if they are trapped in a cave. All they can see are the reflections on the cave wall. From that, they have to estimate what exactly is happening outside the cave. So we just see these things. That's all. Now, why is it so difficult? Because we are mostly used to using our visual senses, our ears. We have learned those things. We have learned to use those things. Radar is not a sensor that human beings are used to using. That is why interpretation is a big problem. And okay, now here I'll tell a little bit of hyperacuity. Hyperacuity is a phenomena in which animals show resolution better than the naive sensors. For example, bats use sound waves. Now, given a wave that is used as an instrument, the resolution is fixed by physics. The resolution can best be c by twice bandwidth. C is the speed of that signal in the medium, and twice bandwidth the bandwidth of the signal. If you use this formula and find the resolution of bats, you get something like a centimeter, like a little bit less than a centimeter for most of the bats. Funny enough, there have been many experiments in which they have put the bats with wire meshes, and the bats can fly very easily around the wire meshes. Now the wire thickness is like a millimeter. How do the bats avoid things that are 1 millimeter thick when their naive sensors resolution is around 1 centimeter? That is hyperacuity, when the animals can achieve feats which beats their naive sensors. Now, how do they do that? This is because bats don't only use ears. They don't just use the sonar. They have eyes. Of course, the eyes are not as good in dark, but still they have the eyes, and they have the skin that senses. So it's all about using multiple sensors and trying to bolster the performance of the one that is not easy to understand. Based on that, I took up, I thought of this new paradigm in which, we have things like radars and sonars and then lidars, which are not easily perceivable human beings. If we can have an optical sensor station in the same platform as the other one, like radar or sonar or lidar, what we do is that when the lighting condition is good, then we operate both these things, let's say radar and a camera. Now, recognition of objects using cameras, optical cameras in good lighting condition is very easy nowadays. Any Tom, Dick and Harry can use YOLO or one of the cousins of YOLO to recognize objects using optical camera. Once we do that, we register the data from the optical camera and the non-optical camera, and thereby we find out which portion of the radar signal correspond to the object that has been recognized. And then we basically are building a tagged training data set for the radar. Now, as you know, machine learning algorithms work best when there are lots of training data, but because we cannot have a lot of training data for radar, that's why they don't exactly work so well. Here, we are building the training data automatically with the help of an optical sensor, and that is why we call it optical oracle. And we filed a patent, and currently a local small company which is trying to design automation sensors for cars, they are using this patent to design a radar-based pothole detection system. So that's just the block diagram of our system. I'll not go into detail of that. Yeah, let me just skip that one. I'll just now talk about few interesting work that we have been doing. One of the very interesting work we have been working on for the last few years is the design of weather buoys or ice buoys for Southern Ocean in Antarctica. You can see, in the right-hand corner, in the ice, you see that black thingy. That's the pedestal. Tip of that is our sensor, the buoy, which collects a few environmental parameters like temperature, pressure, then most importantly, the IMU data, and sends them through Iridium, which can then be used to study the different wave dynamics in that region. Yeah, these are some of the frugal innovations, like innovations around societal problems. I already have talked about the fake medicine product. The second one is the vein viewer, in which we use an infrared red LED along with some infrared radiations to illuminate the veins in hands. It's good for patients who have to be injected intravenous injections. Top right corner is this work on the design of a chatbot for new mothers in African languages. The reason it was very challenging was because the grammar of African languages is very different from the grammar of Indo-European languages. And the one in the top bottom right, right corner is a smart ECG, like ECG using your smartphones. You get quite a few products nowadays in market, but this one is very interesting is because we try to make it as cheap as possible. Mostly the costly part of smart ECG is the ADC. And we thought, okay, your phone already has a sound card and that has an ADC. Why can't we use the mic port to transfer the ECG? Once it is through the sound card through the ADC, it's in digital domain. You can do all fancy DSP to make it clean. And you can see that we could get something very, very clean ECG from this thing. Of course, it's single channel, but that's something better than nothing. And the total cost of hardware was to the tune of 100 rupees. So, and of course, you have to have your own smartphone. Right, the take homes from this talk, the biosphere or the biological animal and plant world is full of interesting engineering tricks. But again, just to repeat Richard Feynman, aircrafts do not flap their wings. So we have to be careful about what exactly we are trying to learn from nature. It may not be always a very good idea to exactly mimic nature. We can get inspired, but mimicking may not be the best idea all the time. Great. So that's the end of my talk, and we can have some quick discussions.
Thank you, Professor Amit. It is a quite good enough for the researcher, and researchers may learn many things from your talk. And I like your different paradigm discussed in this discussion, and each slide having this many different discussion, many different area you have discussed. Okay, in the by inspired paradigm. So thanks. And I have any question, please ask. Hello. I request all of you have any discussion or have any questions they may be asked so that we your work could be proceed. Okay, thank you. So I have one discussion because I am also in this area of this uh, uh, biomedical experimental. Some work has been done by me, and my group we are using the EEG sensor to collect the data of the brain, and different application we have made like your analysis of the brain and the analysis of this memory and the analysis of this your brain activity of this old age and the brain activity of this education students, education peoples like students. Okay, so in the different part you have the collect the different uh, uh, signal from the different lobes. Okay, so from the different lobe we have the suppose in particular some lobes maybe P1 P3 P3 may be collected for this sensitivity, and T1 T2 may be collected for this uh, the brain activities, and some memory part also covered through this T6. So how to segregate whenever you are collecting the data they in a signal manner, how to segregate from one from the others, because somewhere you are putting we are not putting exact things. Okay, exact place we are not getting. So there may be chance of this overlapping of this point, and or there may be chance of loss noise. Okay. So how to eliminate this kind of this problems? Can you suggest me?
I think it's an extremely complicated problem that you have suggested, mainly because in similar problems in industrial applications, you have industry, so you can actually change the industry to get properly validated data. But for brain, you can't change the brain.
Yeah.
So it's extremely difficult to get properly calibrated and validated data. And of course, that is exactly why there are like lots of literature on the denoising of the brain signal. But again, it's not exactly my field, so I won't give answers that I'm not confident about.
Okay, okay. Thank you very much. Thank you. Have any discussion from the anybody?
Yeah, may I just have one query? I mean,
Yeah.
thanks, Professor Amit. Like, it's a very bulk work that you are doing, and you and your team. I must congratulate you. Some new dimensions that you are putting forward regarding this bioinspired computing that you are proposing or you're. But I could not follow one thing. Possibly I missed that part. How you say that a drug is a fake?
Oh, so the counterfeit medicine part, depending on the spectrogram. So before that, we have collected data of the real drug, like spectrogram of the real drug, and that has been stored in the machine learning model. When a new spectrogram comes, it is just it's like a two class classifier problem. Right? So you given a new data, you tell whether it belongs to class 1, which is the real drug, real medicine, or class 2, which is anything else. So does that make sense?
Yeah. And what is it? Is it a single molecular drug, or it may be a combination of multi-molecular drugs also that may work?
It actually doesn't matter because we are not even going to the molecular or chemical constituency of the drug. So for us, the drug is what has been, we get genuine drugs, and that's just like, for us, it's a tablet which you make a solution. And we expect that when the same company is making the same medicine, we should follow the same structure. If it is not the same structure, then it's not the same medicine. So that is the hypothesis. Of course, if the company has changed its own medicine without informing, then of course nobody can detect it. But if we are using the same medicine from the same company, then we don't have to think about the exact chemical constituents of the drug. It is just taken as one. For us, it is just like powder or in solution form. We find its spectrograms, and that is the signature of the medicine itself. We don't go beyond that.
So that means it's basically come down to a kind of an image analysis problem at the
Exactly. Yeah.
Okay, got your point. Thank you.
We are converting that whole complicated chemical analysis problem to, as you correctly pointed out, as an image analysis problem. And that is where the main innovation is. And once you reform because the customer doesn't need to know the chemical content, right? Somebody, Asa Didi in village, even doesn't understand what is chemical.
Yeah.
So she just need to know if this is, paracetamol, this is azithrol or not.
Right. So now, I mean, like, if as you have mentioned, like a particular company will going to have exactly the same spectrogram. So then, do you need a special kind of machine learning for that, or just image to image minor deviation also can detect that thing?
So for that, we have taken a lot of the same medicine from different shops to check if it is, to try to have as much variability as possible in the training data. But that is where we have stopped. So, it's a research work. Going beyond, the future work will constitute of making the sensor more rugged. So now it's very hacky, right? We are doing tungsten filament bulbs. We are using a hack webcam. That's not exactly how a real system should work. So a real system, we will try to have specialized LEDs which transmit a good spectrum of reliable light and a decent type of sensors which can capture with, again, reliability. And these things luckily are becoming easier to make day by day, like pretty reliable set of LEDs and light sensors, which can sense quite a large amount of infrared. Nowadays, it costs to the tune of $50, and $50 is not exactly a lot of money. Thinking of the fact that the same instrument can actually be used for all kinds of medicines, because once you take the spectrogram, the change of the machine learning model happens in the cloud. So that doesn't add to the cost of the instrument.
Thank you so much. Thank you, Professor.
Okay. I hope it is. I hope I will complete this session. Thank you very much once again, Professor Amit,
Thank you.
to deliver a nice talk and for our people. Okay, thank you very much. Okay, so I inform all these authors that they will be joined by 2:15, and next session will be started by 2:20. Okay, please try to join by 2:15, and we'll start the process by 2:10 as 2:20. Thank you very much.
Sir, Srinivas sir,
Yes, anything?
sir, our video will be played, or I have to present myself while presenting a paper.
No, video will be running, but during that period you have to present, and at the end of the session you will be answered.
Okay. Our video will be
We
played.
will declare in this session, in your session we will declare. Okay.
Okay. Thank you.
In presence of the author and also session chair, we will declare the things. Okay.
Okay.
Don't worry about that.